All right. So this is now your ATA 45. So the one that we are seeing now, gentlemen, is the new concept of instrumentation and gathering of information. Before, in the DAS 500, we are utilizing the MFC. How many MFC we have? We have 2 MFC to collect and to authorize the operations of any interface system. But today, for the DAS 600, as per design, we are now utilizing this what you call CAC. What is CAC? This is now your core avionics cabinet. And this core avionics cabinet is something like a systems now that one LRU, which is a lot of systems in it. All right, so that's the process of collections of data now, specifically in recording. So we have the centralized maintenance system, the CMC. All right, CMC. It means to say, gentlemen, a lot of sensors interface to a system and looking after to the status. Any status is specifically a faulty configuration. These sensors are sending information and to be stored in its non-volatile memory for after flight. Maybe we can do some maintenance interface to do some troubleshooting and look for trouble. What do you call it? Look for fault codes in the system. So just like this architecture, gentlemen, you have the CMS, but the CMS has 2 functions. We have the avionic suits as well as the aircraft systems. These aircraft systems, gentlemen, if you remember, we have the AIDS earlier, all right? Your aircraft integrated data system. So it means to say it's collecting data and store it in its memory in order for you to do some maintenance action and monitoring and analysis, doing some analysis on the trend monitoring. That's why, as you can see here, we have the DMU, we have the MPC maintenance system, MFC maintenance function, EEC maintenance function, PEC maintenance function, and the FCU maintenance function. These are all being collected by sensors, and it's now interface to the CMC, centralized maintenance system. So imagine, gentlemen, we are no longer we don't have anymore the what they call this one, what they call this one, the CAP, the CAP. All right, alerting panel, the crew alerting panel, but rather we have now your what they call this one, the lower portion of your EWD, in order for you to be alerted, and from there you can retrieve those information through your MCBU. You go to ACMS, aircraft system, aircraft centralized monitoring system, and from there you can go to CMC, and from the CMC you can do and manage the bike testing of your system interface. All right, so example for this one, the CMC allows maintenance operator to access the following information. So see this one now, the failures detected during last flight and failures currently detected. So there are 2 ways, current and the last flight, something like post flight. Right, so you can access. So you have the avionic suit system provides additional feature, the system report or the system test and report, the system identification and avionic suit configuration report, and the class 2 failure. So imagine, gentlemen, although this aircraft is small, but most likely the technology in place is the same like the technology integrated to big aircrafts. All right. So yeah, you can see this one now, CMC report menu. You can go to last flight report or the what do you call this one? The ground test report. And you have also a provisions to print. Just like I mentioned it to you, we are not only printing all those reports generated during engine run up, but we have also report, you can accumulate also those report as you wish through the printer, and that is via your MCDU.
Perfect.
All right, so we have the aircraft centralized maintenance system allows maintenance operator access through a single interface of your MCDU. You have two MCDU, guys, but it's possible only to do one at a time. One at a time only.
Sir Paul.
Sir, excuse.
See this one now. This access can be performed through both MCDU but not simultaneously. It means to say only one at a time. So let one MCDU access all those basic information. Don't touch the other one in order for you to perform properly. If not, then maybe it can cause trouble also in doing those maintenance fight. All right, so this centralized maintenance system fulfills the following functions. So yeah, maintenance of new avionics system, that is your avionics suit, managed by the CMA application in the cap. What is the CMA application? It's just like a card, something like that, inserted inside your CMA. We are no longer having this, what you call big LRUs. To maximize the space, they just integrated this, what do you call this one, the CAC or the CAC, your core avionics cabinet. And inside this core avionics cabinet, there's a lot of application. And one of them is the centralized maintenance application, or CMA. All right, and the number 2 is the maintenance of aircraft systems managed by the DMU software, part of the MPC. All right. Okay, so we have your CMC. Requires the centralized crew alerting system information from the flight warning application. You see, another application, gentlemen, is your flight warning application inside your CAC. So before, yes, we have your MFC, but now to generate those attention getters, see this one now, the master caution, master warning, plus the chimes and the informations to be presented in your engine warning display. It's now managed by the flight warning application. All right. So see, includes in the system is the PCMCIA card, the MCDU, the printer, and A cards if installed. All right, so now you can see there's a lot of applications, guys. There is a lot of applications. We have the CMA, centralized maintenance application. We have the flight warning applications. We have the auto flight and the DCA. All right, so these are the new applications now inside your CAC. All right, it's something like a card that is inserted to, or memory card, something like that. Memory card inserted to a slot inside your CAC. All right, you see, you have now the how many CAC we have? We have 2 CAC, CAC 1 and CAC number 2. So if there are failures, they are being classified, of course. Class 1, the class 1 is a failure with flight deck effect, which prevent continuous system operation and classified as critical, highest class. That's why if you have that one, it can even give you red warning, or the continuous or the what do you call this one, the warning. It's not the caution, but it's red. And if we talk about red warnings, that is involving the immediate action from the co. Unlike your amber, that is class 2, that is minor failure without flight deck effect, because and that is non-critical. Why? Because of the redundancy of the system. So for the class 1, it can goes also into two kinds. We have the internal failures and the external failures. Internal failures related to be a part of the system and reported by this one example, that is the main component. All right, but you have also the internal failure, that is a failure reported within the system of an interface system. It's not directly. So it means to say, maybe, yes, I have this fault, but that computer is not actually the fault. It's the other system. That is the external failure. All right. So yeah, we have the MCDU. A bionic suit memo provides several services to the maintenance operator. All right, so access to ABS maintenance main menu is done.
Wala ka naman. Sorry, can you check if you can share? Ah, okay na.
All right, test mic, 1, 2, 3. Can you hear me loud and clear, guys?
Loud and clear, sir.
All right. Like, pasensya na, medyo na-delayed lang ng konti. All right. So anyway, I'll take over from the last session last Friday. I was being subbed by Sir Teng because of some emergency situation happened to family last Monday, and of course medyo naka-recover naman tayo, so Tuesday, Wednesday meron pa tayong klase to continue with your navigation system and as well as your structure. All right, to be done tomorrow also. All right, so I think Teng, si Sir Vincent Misahon done with the continuation of your communication system, the CBR as well as the ELT, right? And I think as per advice coming from Sir Chandra, nasimulan nyo na yung ilan yon pang 1, 2, 3 topic. Alright, ano ba yung nakalagay dito? Okay. Saan ba yung sinend mo dyan sa akin na ano?
Sa Facebook, sir, the number 1, 2, and 3, tapos na, sir. Starting from 4 na lang.
So ito na ata yung number 4, di ba? EPIS system. Alright. Okay. Ano tong EPIS? Di ba? Of course, meron tayong EPIS control panel. And what is that EPIS? So meron kayong EPIS control panel. Yan yun. So in order for you to access the different applications of your navigation system, this can be done through your EPIS control panel. And that EPIS is an electronic system which process data supplied from different sources. Ano yung supplied coming from different sources? We have the AHRU, di ba? HRU 1 and 2. We have also your ADC 1 and 2. Alright, your air data computer 1 and 2. You have your AFCS computer. And of course, navigation and ADF. Alright, so that's why you have your navigations. Alright. And your tawag nito yung ADF ninyo, your automatic direction finder, and the display through your cathode ray tube. So ano yon? But that one, gentlemen, display in your cathode ray tube through your EADI at saka ang inyong EHSI via your SGU, symbol generator unit, that process kung ano man yung mga image na ipinupukol ng mga sources na yan. So yung sources na yan coming from the AFCS. Yan. Pupunta yan yung ADC ninyo. Pupunta dyan and ganyan yung AHRU, ganun. So, and in some instances, they are interconnected through your digital buses. Diba? Meron din kayong, aside only from the digital buses, meron din kayong mga linya-linya lang. Ano yung mga linya-linya lang? Those are analog signals. And those analog, pumupunta siya mga main computer na yan. At ano ang gagawin ng main computer na yan? Example, yung symbol generator unit ninyo. Those analog sensors are being, what do you call this one? Digitalized. Example, this one, coming from your knob sensors. Yan. Pupunta siya dyan sa symbol generator ninyo. And the symbol generator will convert that signal into digitalized format and send them in your display unit. Ganon siya. Okay. Alright, so ganito siya. Okay. So, we have those AFCS computer na binabanggit natin kanina as one of the interface. AFCS, your symbol generator, and the navigation system, di ba? May mga navigation systems kayo. And all those things are sending inputs to our symbol generator. Is it symbol generator number 1 and symbol generator number 2? Now, paano siya ngayon may ipipresent sa inyong display unit? So it's a matter of selecting an application doon sa inyong EPIS control panel. If you select using these rotary knobs and push button switches, it sends a signal to your symbol generator unit 1 and 2. And this symbol generator unit process that signal and send them yung mga applicable data to be viewed in your EADI and your EHSI. All right. Now, kita nyo mga kapatid, that is the normal configuration. Yan, that is the normal. But there are some instances, gentlemen, that how about if the symbol generator number 1 fails? What will happen? So the FO lights illuminate as well as the system 2. It means to say the supply now coming from the symbol generator, nawala na yan, di ba? Nawala yan. So ano ngayon ang display unit ninyo? Sino ngayon ang magpo-provide ng information papunta doon sa inyong captain? Kaya nga, meron kayo nito. EP's reversion parallel picture bus. So it means to say, since nasira yung symbol generator number 1, it's the symbol generator 2 that will supply. Kaya nga, meron kayong ganyan. Yun. Meron kayong ganyan. Through your EP's reversion parallel bus. So it's nakaangkla or naka-slave ang inyong EADI at saka EHSI number 1 sa symbol generator ng number 2. And that is also true in an opposite operation. So example, kung masira naman si symbol generator number 2, ano ay nang mangyayari? So kikita niyo naman to, may indications kayo. And what to do? Siyempre, kung nasira na yung symbol generator number 1, wala na kayong ganyan. Sino ang magpo-provide ng information doon sa FO display unit ninyo? Coming from the generator number 1. Now, paano kung nawalan kayo ng symbol generator number 1 at saka symbol generator number 2? Kumusta naman ang display unit nyo? Di wala. Diba? No worries mga kapatid kasi meron naman kayong standby instrument. So yung standby instrument na lang yung gagamitin ninyo to monitor your aircraft flight. Wala tayong magagawa. Ang nasira mismo is yung display unit. Yung symbol generator unit mismo yung nasira. Di wala tayong magagawa mga kapatid. Ngayon, paano naman? Ito naman. Paano kung ganito? Sandali erase lang natin to ng konti. Right. Paano naman kung display unit lang yung nasira? Ano ang remedyo dyan, kapatid? Ano ang remedyo natin dyan? Walang problema. Diba? Wala pa rin namang problema. Bakit? Kasi meron tayong tinatawag na, tawag nito, nakalimutan ko. Yung information ng, halimbawa, nasira yung EADI. Bababa siya. Ayan. Paano kung ang nasira naman ay yung display ng lower? Anong mangyari? Yung basic information, aangat din siya. Ayan. Meron tayong ganyan na sistema. Kung masira yung display unit, bababa yung essential display information doon sa operative display unit. And that is applicable for either up and down. Diba? Up and down na. So, yun lang ang pero kung halimbawa, nasira na yung both display unit, di wala tayong magagawa niya. Diba? Wala tayong magagawa. Anyway, walang problema kasi baka naman meron ka pa sa FO. Diba? Or meron ka pa namang standby instruments. Alright. So, yung systems natin mga kapatid, nakikita nyo, ang inyong display units and even the symbol generator for the captain side, mga kapatid, is powered by your standby bus. You see that one? Naka-standby bus kayo. Alright, meron kayong standby bus. So in case of emergency configuration, the standby bus is still supplied. It can be supplied coming from the battery, or it can be supplied coming from your AC wild generator. Maybe you lose yung inyong normal buses kasi doon sa FO side, you can see it's normal bus ang nagsusupply doon sa sistema ninyo. In case of emergency, maybe you lose your normal bus. No worries. Why? Sa FO side, hindi naman siya magpapalipad ng aircraft. Sino magpapalipad ng aircraft? It's the captain flying. Anong gagawin ni FO? Di tagabasa ng mga procedures na ididikta niya doon sa piloto to aid the pilots in flying. So nakita niyo mga sirs yung importance ng mga powers natin regarding sa operations ng inyong display system. Alright, so example dito. So two symbol generator. Meron kayong dalawang yung EPS control panel for dedicated captain and FO. And you have also your captain instrument computer for a controller to change the course. Yan, tag-isa sila ng course. Ito yung selection ng mga bugs ninyo. And you have also doon sa captain side heading, pero doon sa FO it's the altitude. So if you want to change that one, what will happen? Example, altitude select. Papaikutin mo ngayon yung altitude select, pupunta siya ngayon doon sa AFCS nyo, and from the AFCS, pupunta ngayon doon sa ADU, at nakikita nyo ngayon, yan na ngayon yung altitude select. Alright. So, how about for the other one? Change ng course ninyo. Pilitin nyo yung course, pupunta sa symbol generator, and then, from the symbol generator, pupunta na siya sa inyong EHSI. Ganun siya. So, that is also the same aspect for your controller or the remote control FO remote controller. Course number 2. So what happened? It sends a signal to your symbol generator, and from the symbol generator, it gives you now the bug for your course. Kaya meron kayong course dito. Kaya meron kayong course. So this EPS display pitch roll attitude. So you have the pitch roll attitude, you have the heading course orientation, the flight path commands, weather data, optional terrain data, the flight director mode, source annunciator. So aircraft equipped with GNSS can also be displayed GPS waypoints, navigation information, and the advisory navigation. Kaya nga, ang dami yung mga inputs, mga kapatid, relating to navigation system. So, kikita nyo yung mga yan. And from there, it sends signal sa inyong symbol generator. And from the symbol generator, it will be processed and it will be displayed in your display unit. All right. It will be displayed in your EADI, electronic attitude deviation indicator, and your electronic horizontal situation indicator. All right, and yun na nga, the symbol, ayan, ito tingnan nyo mga sirs, ito yung binabanggit ko sa inyo kanina. All right, so example, nasira nga yung symbol generator, so most likely, wala na yan, di ba? But you see, the symbol generator number 1 is still active. So normally, he is supplying your display unit. But you see this one, through your EPS reversion bus, it's a two-way communication. So it can still supply your FO side. It means to say this EADI and the EHSI coming from your FO is now a slave coming from your system number 1. All right, so you can see a symbol generator can drive all the 4 display unit, so that if a symbol generator fails, the remaining symbol generator drives the display both sides of the cockpit. All right, napaka ano yung sinabi niya, napakalinaw nung sinabi ng ating notes. Alright, now ito ay yung sinasabi natin kanina. Paano kung nasira yung isang display unit? Alright, anong mangyari if a display unit fails? Ito ang tinatawag natin kanina. Ano yung term doon? We talk about composite display format. Yan. So it means to say the what do you call this one? Information will go doon sa taas. Ang tawag niyan is composite mode. Alright, please take note of that one, guys. Yeah. Display can be displayed the remaining operational display unit on that side of the cockpit. Alright, that is what we call composite display mode. Alright, kahit nasira yung isa, pwedeng tumaas, pwedeng bumaba. Yung yung sabi natin, pwedeng gumanito or pwedeng tumaas. That is your composite mode. All right, so yeah, the crew manually select the different attitude. So attitude, so meron kayong depende, and the air data and navigation sources for display in the EP's control panel or remote switches. So you can select through your EP's control. Yan. Pwede kayong mamili. So if not the rotary wing, you can use that one. Hard keys in your EP's control panel. So anything via serial bus goes to your symbol generator. And of course, present it in your display unit. Alright. So ganon din yung remote controller ninyo, yung nabanggit ko sa inyo kanina. We have course 1 and course number 2. So kikita nyo yan. Yan yung course 1 ninyo. That is also your course number 2. Of course, we have the heading for the captain and the altitude. The altitude goes to your AFCS computer, and then it will present your altitude heading select. All right. Okay, two symbol generator monitored within the EP's comparison monitors. Kaya nga, kinu-compare yan mga kapatid. That's why you have the EP's reversion parallel picture bus. Para kung ano man yung i-compare niya kung ano yung mga naka-display, and not only that, but through your ASCB bus. Ano yung ASCB? Avionics Standard Communication Bus. Alright, so yeah. Okay, so you have your EADI for both captain and FO. That is on the top ng display unit natin. You have the electronic horizontal situation indicators, which is located below your EADI. You have the remote control for captain and the FO. So for this one, this is captain side because heading, yung isa is tawag nito yung altitude. So we have the EADI for FO, the EHSI for FO, and now you have the captain switching. So kita nyo ito mga sirs, just to give emphasize on this one. Kanina napag-uusapan natin yung EP's symbol generator, di ba? Ilan yung EP's symbol generator natin? Dalawa. This one is just the FO. So ibig sabihin, meron din kayong switching doon sa captain. Di ba? So just like, kung halimbawa, nasira nga yung symbol generator ng number 1, iilaw to, it means to say, the FO is supplying information through your EP's reversion bus to supply yung inyong EADI and the EHSI from the captain side. All right, this one is captain. Okay. So, but you have also this one, you see. So, the same also. Kung nasira rin yung captain, then magi-illuminate din. So, but you see, guys,
it's a redundancy of the system. It's not only in effect in your EP's symbol generator, but also in your BOR-ILS and in your attitude and heading. Ilan ang AHRU natin? 2. So kahit masira yung isa, walang problema. Paano yung VOR and ILS? Ilan yung transceiver ninyo? 2 rin. So kung masira yung isa, you still have the other side. So yun ang kagandahan ng sistema. But yun na nga, kung masira, ibalik natin Ibalik natin. Alright. Ano na lang kung ganun. That's why, kikita nyo to, you have the EPX reversion parallel picture bus. Diba? Para kung masira yung isa, the other one will be slave coming from the other system through your EP's reversion parallel picture bus. So mawawala yung linyada dito. Pero you still have this one to support the information of the opposite side na nasira. Diba? So yan yung, kaya meron kayo nito yung EP's SG at saka Captain SG. Ayan. Alright. Then you have now yung EPs. So nakikita nyo dito sa EPs, you have a rotary selectors, mga kapatid. And you can select either RNAV, the ADF, VOR. This is the system number 1, circular, bearing. Alright. But you have also your system number 2, RNAV 2, ADF 2, VOR number 2. Alright, and off. Something like that. Then you have all these are rotary selectors that can be provided in your display unit, but you have also this one. You see, especially in your EHSI, there is a picture here, full or arc. Full, you can see the full picture of that display unit. But if you press it again, there's a probability also to give you arc mode. So you have also your map mode. You have also the ground speed. All right. And the TTG. What is TTG, gentlemen? That is time to go. All right. TTG, time to go. We have the VL and the RNAV. So, anong gagawin natin dito? So, pipindot lang. So, dalawa yung EPs. Captain at saka yung FO. And then, we have also the FD bars. Dalawa yung FD bars ninyo. Where can you find the FD bars? The FD bars is located in the glare shield. It's a toggle switch. So, for you to monitor yung inyong EADI, yung crossbar niya. So, that crossbar, gentlemen, so, it can be controlled by FD bars toggle switch. So pwedeng ipag nilagay nyo sa FD bars, so makikita nyo yung red vertical at saka tawag ito, yung crossbar, I mean the crossbar. But if you place it off, then mawawala yung crossbars ninyo doon sa inyong EADI. Ito na nga yung FO switching. So redundancy, mga kapatid, dalawang symbol generator, dalawang VOR ILS transceiver, at saka dalawang AHRU. So attitude heading reference unit, dalawa. So masira man yung isa, nothing to worry, redundancy of the system. The opposite, which is the operational system that is in control with the other system, can still control to the other side through your reversion bus. Alright, so yan na nga, dalawang symbol generator. Alright, and you can see, guys, you have your HRU1 at saka yung HRU number 2. And those AHRU, or the attitude heading reference system 1 and 2, can supply both system or the symbol generator number 1 and the symbol generator number 2. Alright. And of course, you have two EPs which can be selected independently by the pilot. All right, so Captain Instrument Remote, ito na nga yun. So it can goes to your symbol generator and can also through your symbol generator, it will now be presented in your EHSI. Right. So interface with the Captain SGU to supply independent selection of course. So independent selection ng course ninyo. Kaya nga sa EHSI, nakita nyo kanina yung dito, we have course. And also heading, nakita nyo dun sa baba, meron din siyang heading, display, and common selection, common selection for heading, as well as yung inyong altitude. Yan, dito naman sa FO remote, ganun din, independent supply. Pero yung nga lang, yung altitude niya is through your AFCS computer and to your ADU, Advisory Display Unit. And so you can change the altitude. It sends the signal to your AFCS computer, and you can now monitor the selected altitude in your Advisory Display Unit. Okay, about this one. So energization of your display, gentlemen, is through your EPS control panel. So if you place it to off, then what happened? It can goes to off. What happened, gentlemen, if you set it to off? Simulation, gentlemen. Simulation na nasira ko na siya. So anong mangyayari niya? It can goes to composite display. Yan na yung binabanggit ko sa inyo kanina. Alright. So hindi lang yung faulty code, but even in the off configuration, it goes there as a form of composite mode. Sinasimulate niya kasi na if you set it to off, it will be simulated as defective, yung display unit. So if that's the case, it can eventually goes to composite mode. Alright. Okay, so ito na nga yung ito na nga yung composite mode display ninyo. So tingnan niyo mga kapatid, nasira yung inyong o sabihin nating off yung inyong EHSI. So what happened is some of the information nandun na sa ano ninyo, sa EADI. Alright. So yan yung tinatawag nating composite mode. And that is parehas sila. Pwede rin kung nasira naman yung inyong EADI, what will happen? Bababa rin siya if the EHSI is operative. Paano nga kung sabi ko nga sa inyo nasira. Alright, nasira yung both display unit ninyo. Walang problema. Diba? You still have the emergency or the standby system of instrumentation. Doon tayo mag-rely. At least the standby instrument still gives you the at least basic information to fly. Alright. Kaya katulad nito, you know, if one SGU fails, Red Cross, so kita nyo, Red Cross, wala na yan, di ba? Red Cross and the relevant EADI. Bakit? Kasi nasira na nga yung wala na kayong linyada. Wala na kayong bus video. So ano mangyari? Yung display unit nyo. Pero ganun-ganun na lang ba? Di ba? Siyempre hindi. Ano yung mga remedyo nga natin, di ba? Ang remedyo nga natin dyan is yan, makikita nyo kung SG fail. Alright. So makikita nyo, symbol generator. So if that's the case, PP.in, recover the information of the captain, EP's SG post button has to be pressed. So please do it. Ayun. So dahil pinindot ko, na-recover niya, umilaw ngayon yung captain at saka yung system number 2, indicating in the captain side that you are utilizing the system number 2, the symbol generator number 2. Alright. At alam ni FO na, si captain nakikigamit. Diba? So, at marirecover mo yan through your symbol generator via your EP's reversion parallel picture bus. But this one, this information, gentlemen, is now a slave. slave na siya ng inyong system number 2. Alright, so if that's the case, what will happen now? Then, mayroon kayo ngayong ilaw doon sa byte advisory display ninyo. So, maaring may nasira siguro sa mga display unit nyo na yan, EADI, overheat. Kaya nga din nyo ba alam na pag-usapan natin yung, ay hindi, doon sa kabila ata, air conditioning system. And part of the air conditioning system is ventilation. Through its ventilation, mga kapatid, anong nangyayari? Siyempre, may cooling system kayo sa inyong mga display unit. But example, nagkaroon nga kayo ng overheat, then ano mangyayari? Meron kayong amber indication. So all you have to do is to, during maintenance, anong gagawin natin? Paikutin natin to, yung selector switch natin, and look for fault codes. Alright, we look for fault codes. Alright. So yeah, nakita nyo na to kanina. So in the normal configuration, the captain side is always supplied coming from the standby bus. But for the FO, they are supplied coming from the, what do you call this one? Coming from the normal bus. So if normal bus fail, you can still recover the information through your captain side, because they are always supplied coming from the battery in case of emergency, or through your transformer rectifier via your ACW, di ba? Yung AC wild natin, AC wild. And that will be converted by the TRU from AC to DC to supply your standby buses. All right. Okay, this one question. EHSI or EADI composite mode is obtained by switching off the opposite CRT on the ACP, automatic selection of the SGU in case of failure of the opposite CRT, or pressing the AC, the SG switch. So that is automatic, mga kapatid. No need, dito manual to, minamanual mo. Pero in cases maybe, there is an automatic mode that will allow the composite mode to allow the basic information to transfer to the operational display unit. And that is vice versa. Alright, so yeah. Ano ang nasa loob ng inyong symbol generator unit? Ayun. So, as you can see, example is you have your symbol generator number 1. So includes 3 main parts. We have the data input, collecting inputs coming from navigational instrument. You have the ASCB input and output. So ASCB, you have the what do you call this one? Cross-talking. A cross-talking between SGU, di ba? That's why if we go doon sa ano natin, nakita nyo, di ba? So there is a direct communication between the SGU number 1 and the SGU number 2 via your ASCB bus. That is the input and output ASCB. Ayan. And of course, the number 3 is the symbol generation. So part generating the pictures and send it to your EADI and your EHSI. So yan yung kaloob-looban ng ating symbol generator number 1 and number 2. Alright, so yan, katulad yan, kaya nga may cross-talking sila, and that is digital bus. That is the input-output of your ASCB. Yan yung application yan. ASCB input and output through your ASCB. And they have a direct communication between each other. Kaya nga, kapag nasira to, huwag niyong tanggalin, nandun pa rin siya. Kahit sira. Bakit? Wala namang problema kahit nandyan. Diba? Para alam niya na, oy, sira ako. Then you take charge. Diba? But taking charge of that is through a switch. Alright, so i-switch ninyo. Yan, the symbol generator unit is the heart of the EP system. The receive input comes from yung mga GNSS, navigation, DME, ADF. And of course, EP's comparison monitoring. Kaya nga, sa loob niya, meron kayong symbol generator for comparison. Alright. So ano pa? Even the radio altimeters for radio altitude, for decision height. Kaya nga, pihitin nyo to for tawag nito, yung selection ng ating decision height, which is can be selected decision height through your EP's control panel. And we have also the airspeed. The airspeed indicator for display of airspeed deviation. And you have the EH R1 or 2 and your weather radar. So all these things must be processed through your symbol generator, and from the symbol generator, it will now be presented through your display unit in your EHSI as well as to your EADI. And you see this one, AFCS mode annunciators, heading selection, flight director command, and coupling information. If you remember the auto-flight system, gentlemen, you have one computer. So that is the AFCS computer. And you see, although nag-iisa siya, pero siya yung nakakaalam doon sa sistema. Alam niya na dalawa yung sistema because they have the, what do you call this one, the ASCB, your Avionics Standard Communication Bus, which is a multi-directional between two other computers. Alright. So, kung nasira yung isa, kaya nga single lang siya. Pero kung buhay yung dalawa, anong nangyari? Coupled siya. Kaya nga doon sa autoflight ninyo noon, di ba, meron kayong parang dalawang arrow, pointing captain and pointing FO. If both system is operating, then it's coupling. That's why you have the coupling information. Dalawang arrow is pointing to the captain and FO. But say for example, degraded yung system, symbol generator fails, then it becomes single. Alright, that is the interface of your AFCS. Alright, so all inputs are processed and transmitted to the electronic display by video signal as a function of the selection made in the EP's control panel. So whatever applications you select through your EP's control panel and the inputs coming from your navigation system, it will be processed through your symbol generators. And that symbol generators now, it sends now a bus video to be presented and distributed to your display unit, your EADI, as well as to your EHSI. All right, so you see this one, purpose of your symbol generator unit, forms all symbol, alphanumeric, text, and colors display in the EADI and EHSI cathode ray tube. So that is the purpose of your symbol generator. So you have symbol generators. Where can we find the symbol generator? They are located in the 80 VU, specifically 83 and 82 VU. So dalawa. All right. Meron kayong dalawa. Okay, so yung SGU number 1 ninyo is yun na nga supplied by standby bus, and the SGU number 2 is supplied by main bus number 2. All right. So normally, yeah, supplies the symbol generator supplies the on-side EADI and your EHSI. So these signals are used to validate the comparison function of your roll, pitch, attitude localizer, and heading comparison. So it's through the processing inside your symbol generator. And you see, that's why you have the comparison function, validate the comparison function between the information sent by the sensors to both SGU number 1 and SGU number 2. Kaya nga meron kayong comparison through your bus ASCB. So kinukumpare niya ngayon para pagdating dito sa processing, kung ano yung nakikita dito sa captain side, dapat ganun din yung nakikita doon sa FO side. Ngayon, meron tayong problema minsan. Nagkakaroon ng tawag nito yung mismatch. So kung malaki yung mismatch, hindi sila magkapareho. Example, may sirang sensor, mga ganun. So most likely, that's why each system has its own sensors to indicate kung ano yung status niya. So kung ano man yung status niya ngayon ng system, so ibibigay ka, example nito, meron kayong nakikitang mga XX. Di ba pwedeng ano to? So meron kayong X, ibig sabihin wala kayong localizer, parang ganun. Walang localizer. Yan. And that is also on the same side. So if both coming from your outside sensors processed by the symbol generator are the same, then they will be shown. Wala silang mismatch. Yeah. Pero kapag there are some, yung mismatch na sinasabi natin is magkaiba, example, yung heading, di ba? Or yung sabi na lang natin course. There are some instances, example, the course number 1 and the course 2 is actually independent. Kaya normally, hindi sila talaga magkapareho. Pero there are some instances na yung course na sinelect ng captain is also the course selected by the FO. If they are the same selection and then they have discrepancy, then meron kayong mismatch. So it means to say sensor fault. Meron kayong mga sensor fault yan. Alright, so yeah, eto nabanggit na natin to kanina. So if symbol generator fails, what will happen? No worries, we still have your symbol generator number 1. Through your EP's reversion parallel bus to supply on the opposite side, which is defective, di ba? Defective yung symbol generator niya. Alright. So yeah, this configuration is achieved by the pressing pause button on the affected side. So if you press that one, the system number 2, yung isa naman is FO. Alright, so paano naman to? One EP's panel is provided to the captain and first officer, allowing selection of EP's mode on mode and screen brightness. So they have independent EP's control panel. So that serial bus now, digital signal transmit selection from the EP's control panel to the corresponding SGU. So kung ano man yung pinindot mo dito, it can be selected through your rotary selector or through your hard keys. It sends a signal that is your serial data bus, and it will be processed by your symbol generator unit. And from there, transmit now. Example for this one, panel transmit medium brightness control signal to the EIDI and your EHSI. So you can control also the brightness, not only those what do you call this one, soft hard keys that can be selected by pressing those pause button or by rotating those knobs. Ito na nga yung binabanggit natin. So yeah, you can you have 2 EPs which can be located in the center pedestal. All right. Okay, so pag-usapan natin isa-isa. Meron tayong tinatawag na hard key kanina, di ba? Yung hard keys natin. So meron kayong full or arc. So pag pinindot mo yan, it can change the graphical picture. So example for this one, this is a full compass. All right. That is the full compass. But if you press it again, it changes to partial compass. This is arc. Alright. So ganyan lang, nagbabago. Pwede yung baguhin yung itsura depending on the selections done by the pilot. Then you have also map. Pag pinindot mo naman yung map, ayun, nakikita nyo, this is the map mode. Makikita nyo ngayon yung waypoints. Or by pushing the map post button, the arc display can change to map format allowing waypoints. So we have the waypoints active, flight plan to be displayed within the range scale selected by the radar. All right. Okay. Yung range ninyo mga kapatid, nakikita nyo itong range na to. All right. Nakikita nyo yung mga range na yan. Wala sa APIS yung change ng range, kundi nasa radar. All right. Radar. Sandali lang. Mamaya ipapakita ko sa inyo, may range doon. So pwede nyong i-select yung range. Example for this one is 100 nautical miles. So ano ngayon ang susunod dito? Maaaring 200 nautical miles. Alright. So if weather mode naman, so weather information can be displayed. So kung weather naman, maaaring makikita nyo yung ulap-ulap dyan sa inyong EHSI. All right. Then you have also the ground speed and the time to go. Pushing the ground speed, so you can have the ground speed. Okay, kita nyo dito, ground speed. And pushing again, you can find the time to go. All right, time to go. And then you have also the VL. Yeah. VL, V is representing the VHF, L representing the localizer. So if you press that one, what will happen? So you can find the VOR localizer mode selected. So VOR1 or VR2. So kaya nga pwede kayong mamili VR1 or VR2. And the next hard key also is the RNAV. By pushing the RNAV, the GNSS mode is selected. So 56.1 nautical miles. All right, then you can see this one. This is the rotary, bearing 1 at saka bearing 2. Yung system number 1 ninyo sa left and system number 2 sa right. So yung lahat ng circle, so it can be VOR1 ADF and the RNAV1. And the diamond that represents your VOR number 2, ADF number 2, and RNAV number 2. So ano yung makikita natin dyan? Yun, meron kayong bearing na green. Ito ngayon, yung system number 2. It means to say that is the ADF number 2. And yung circle naman yan, that is your ADF number 1. Alright. So kaya nga yan. Yan yung ADF ninyo, and you have the ADF1. Yung ADF number 1, ito. Yung ADF number 2, yan. And also, VOR. Yung VOR ninyo is this one. It can also be selected VOR number 2 by selecting your VOR number 2 in your EFIS. All right, and then you have also your dim control knob. So selection off to bright, something like that. So dim knob set the brightness for its display unit. After the reference level is set, the photosensor, all right, on its display unit maintains the display brightness over varying cockpit lighting. All right. So kaya nga mayroon kayo dito. Doon sa display unit ninyo mga kapatid, you have also this one. Ano yan? Yan yung photo sensor on its display unit. So pwedeng off to bright, di ba? Off to bright. So nag-illuminate siya pero nag-a-adapt siya. Depending on the varying cockpit lighting condition. So we have also this ADI dim, outer knob. So we have the outer knob and the inner knob. All right, so tuning the ADI dim, adjust the overall brightness on the EADI. And then we have also the off position, EADI off, select a composite mode. Ano ibig sabihin niya? Kapag in-off mo yung outer knob, anong mangyayari? Simulating that the display unit is faulty. Ano nga nang mangyayari? Maglilipat siya. Yan yung composite mode natin. Lilipat yung mga basic information or the essential information doon sa operating display unit. Alright, then you have also your EHSI dim. Same also, we have the inner and the outer knob. Yeah, that selects also the brightness and of course to serve also as off. And if you off the EHSI that or the EADI, what will happen? That's why sabi ko sa inyo kanina, it can be opposite. Kung nasira ito, bababa. Kung nasira ito, ano mangyari? Tataas din siya. Ganon siya. All right, and then you have also this weather dim. All right, you have also now the weather dim. So ganon din. Anong mangyayari ngayon dyan? So turning the weather dim knob adjust also the overall brightness ng inyong weather radar. All right, so what else? So the off position removes the weather radar or terrain information if a composite mode is displayed in the EAHI. Anong gagawin ninyo? You set it to off position. All right. So ganyan yung function ng ating mga control units, mga kapatid. All right, and then you have the decision height. All right, that decision height, gentlemen, so depending on the pilot, they will select the decision height. So we have also the inner and the outer knob to display the decision height. Decision height can display adjusted to 10-foot increment between 200 to 999 feet and 5-foot increments below 200 feet. So turning the DH knob completely counterclockwise removes the decision height. So that's why you have this decision height. All right, how about the test? All right, you have also the test. The test knob, push on ground display, enter the test mode. So the test mode plugs and caution are displayed. So nakikita nyo ngayon dun sa inyong display unit, lahat ng mga nakikita nyo test at lahat ng mga plugs is nakikita nyo, di ba? All right. So testing, at least testing the display unit. So test routine displayed the radio altimeter. All right, that's why you have the RA in 100, that is the test value. All flags view in red X in those pointer scale. The command bars, meron kayong command bars, your FD bars, and of course the test magenta. All right, the test magenta. So note that the EPIS test is functional only on ground. All right, so test. Okay. Ano pa yung mga makikita natin dito? Ayun, so ECP. So naulit-ulit, so you have the standby bus and the main bus to supply for both captain and FO. All right. Okay, guys. So yeah, for the captain instrument remote controller, so heading, okay. Kaya may heading kayo dyan. That is common to both captains or pilot. you have your heading bag. Right. Heading, that's why you have this one through your symbol generator. It goes to your symbol generator, and then you have the heading. All right. So what else? You have also your FO, but for this one, it's the course only. It's not common. It's not common. The only common is the altitude, which is located in the ADU or the advisory display unit. Ayan. So altnab, the altitude, is common to both pilots. Sends a signal to your AFCS computer, and it will be displayed in your ADU, advisory display unit. All right, so where can we find this one, guys? These are located in the glare sheet for both captain and FO. For the display unit, specifically your EHSI, navigation information required for medium and long range navigation. So ang dami nating mga makikita dito, mga sirs. Di natin isa-isahin na to. Makikita nyo naman meron kayong namang notes, so kahit papano makita nyo yung mga display units. Anyway, as we go on, pinag-uusapan naman natin kung ano yung mga interpretation ng mga display units na yan. Ayan. So I think na natapos naman na natin yung full and arc. Ayan, ito yung ang tawag nito, yung composite mode na sinasabi natin. Yan. So anong makikita natin sa EHSI? So yan, mga heading, blah, 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 blah. Anong makikita nyo sa partial compass display? Halimbawa, this is the normal. Okay. The normal. Ito yung normal. Full compass display. Yan. Pero kapag nagkaroon siya ng partial, ano ibig sabihin yan? Example, yung ano ninyo, itong arc mode. So mas kukunti yung ano niya, yung pinapakita niyo. So ito siya. Yung ito na to is doon sa kabila. Mas malaki yung binibigyan niyang information kapag naka full compass display siya, unless otherwise you selected it to partial by placing the arc or full pause button, pressing that one, so it can change the configuration of your display unit. Alright, ano pa? So radar, ito yung sinasabi nating range kanina. Alright, range. Doon sa radar ninyo, di ba meron kayong range? Ito yung range ninyo. Yan yung mga range. Yung range na yan is sineselect dito. So it's just up, 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 down, down, down. Ganun lang siya. So radar operating mode. So normally, it's in the standby. Meron kayong standby. So kapag na-standby, the weather radar control panel, so that the range information is transmitted to the symbol generator. So brightness, radar return can be adjusted by the dim weather, inner knob, and the ACP, and off of this knob, remove the weather radar information. All right. So nakita nyo ito kanina, weather dim, to control the brightness of your display unit. Alright, tuloy lang natin mga sirs, and then after that we'll have our long break at 6 p.m. Anyway, it's 20 minutes na lang. Alright, so yeah, ito na nga yung binabanggit natin kanina. So normally we can adjust the brightness, di ba? Yung sinasabi natin kanina, at the dim, the inner knob, But after selecting the brightness, anong nangyayari? Because of the photo sensors, nag-a-adapt na lang sa variable light environment ng cockpit. Yan, nag-a-adjust siya. Yan, varying cockpit lighting condition. Ito na nga yung binabanggit natin. So, what happened if you off mo siya? It will be simulated as defective. Or maybe display unit mismo yung nasira. What happened? No worries because you still have the composite mode. That composite mode displayed the information to your operating display unit. Hindi man ganun karami, but the essential, sabi ko nga sa inyo kanina, the essential display in your EHSI transferred to your EADI. All right, so yeah, locations again of your display units, they are located in the instrument panels. So to power up of your EHSI, you have the knob. All right, to increase or decrease, or if you set it to off, increase, decrease, that is the illuminations, but you will have the still the options to set it to off. And you can see if you set it to on, there's a lot of informations that can be provided in your EHSI. So, okay, kita nyo, we have the course, we have the target, weather, we have the VOR, the bearing information. Right, and of course, even the heading, and then you have the lumber line, the aircraft symbols, the heading display dials, the 4 lumber lines, and the heading selected bug. So, you have the heading, right? Kapag ginanon ni Kapitan, it selects the heading, and also the bugs will move as selected. So katulad nito, ang select niya is 319. So most preferably yung bug na yan is heading, that is the heading as selected. Okay, so napakarami mga kapatid yung mga informations na makikita natin doon sa inyong EHSI. Hindi na natin iisa-isahin yan. Alright. So, hayaan nyo si Captain Romer ang mag-interpret niyan. Ang concern natin mga kapatid is kung nasira yung display unit, anong gagawin natin? Diba? Pwede ba nating tanggalin? No, wag yung tatanggalin. Hayaan nyo lang siya kasi meron naman siyang applications na pwedeng lumipat nga doon sa available na display unit. Alright, napakarami mga kapatid. Hindi na natin isa-isahin yan. Alright, dito sa weather, tingnan nyo sa weather mode. So, green, kapag green kayang-kaya pa, pero meron kayong something like level of precipitations. And that can be labeled depending on the, tawag ito yung bugso ng moisture. Kung ilang millimeter. Alright. So, level 1, kayang-kaya pa. Pero wag sana pumunta doon sa magenta or doon sa RCT. Alright. Na hindi na natin alam kung kakayanin natin or hindi. Kaya nga normally, alam natin ang range, di ba? Yan o, katulad nito, 25 nautical miles ang range yan. So most likely, the other one, it can be 50 also. Alright, ito na nga yun. This is very important mga kapatid. Okay, very important. So, kung nasira yung from the failed EADI, pupunta EHSI, ito yung mga datang kasama niya. Diba? Lilipat siya. Example, you have your 2 display units, diba? Yan. So this is the EADI. So kung nasira yung EADI, it will transfer to your EHSI. So kung nasira naman yung EHSI, ito naman yung mga information na dadalhin niya para ilipat niya doon sa inyong EADI. Ano ang tawag niyan mga kapatid? Yan yung tinatawag nating composite mode. Alright, ano pa? Ganon din kanina. Supplies ng ating display units coming from standby bus and your DC main bus number 2. Okay, so yeah, in normal operation, the EADI image is displayed in the upper. And it presents primary flight information, requires short range navigation. Alright, so yan yung mga makikita natin sa ating EADI. We have the localizer, the glide slope, the attitude. Alright. And ganun din yung mga makita natin. So hindi na natin iisahin. Ito, it's for you to explore mga kapatid ko anong ibig sabihin ng mga basic information as presented in your EHSI. I mean EADI. Yan. So ano yung mga makita? So you have the attitude. All right. This is your attitude, your pitch, yeah, and the roll. We have also the fast and slow information, the glide slope. So we have your glide slope information. We have the localizer, deviation. We have the supposed to be dito yung marker beacon ninyo. All right. We have also the ano pa? Yung radio altimeter. So you have your RA, the guidance, so you have your FD bars, and the auto flight engagement. So those are the informations that we can find in your ILS, EADI ILS approach. So kailan niya mga kapatid kapag pinindot nyo nga yung VL, yung VL, VOR at saka localizer. So magpapakita yan. And ano pa, meron nga kayong lateral acceleration, the slip and skid. You have this one. So normally, anong gagawin natin? Yung bola must always be in the center para malaman natin kung well coordinated yung flight ng aircraft natin. Alright, so brightness, yan na nga yung sinabi natin kanina, yung EADI dim. And as soon as you set it, it will just adjust through the photo sensors as provided in the display unit. And it will, what do you call this one? Mag-a-adapt na lang siya sa condition ng yung varying cockpit condition lighting ng cockpit natin. Alright, so yeah, kapag yun na nga, failure, kapag in-off mo siya, EADI, you place it to off position, what will happen? Simulate, gentlemen, as faulty, naka-faulty siya. So what happened? Ayun, nilipat siya. And that is your composite mode. Alright. Ito, nabanggit na rin natin to kanina. it's for you now to explore the different indications of your EADI and EHSI. Okay, in the EADI. All right. So I think that's all, gentlemen, for our display systems, which is managed and controlled by our symbol generator. All right. So baka may questions kayo mga sirs regarding the interface of your EPIS system, your electronic flight instrument system. All right, so if none, I think we need to go to another topic. All right, let's go to your viewer system. All right, part of our navigation is our VOR or the VHF omnidirectional range. So itong VOR systems ninyo mga kapatid is a navigational aids which measures the radial from a facility, meaning 1 degree increment. All right, and the display units of bearing information is makikita ninyo sa inyong RMI. So doon sa RMI nyo mga kapatid, you can actually choose VOR1, ADF1, or VOR number 2, or ADF number 2. So yung nakita nyo kanina mga kapatid, bakit meron ding information ng VOR doon sa EHSI and EADI? Yes, of course, those are normal. But just like I mentioned ito yung, paano kung nasira yung display unit ninyo? Paano kayo makakatingin ng mga basic information towards a particular VOR station? So no worries, because you have your standby instrument. Your RMI, mga kapatid, is considered as backup system, or this is used in case of the normal display units fail. So this system provides oral signal to allow VOR station identification. What is that, gentlemen? You remember dati yung communication natin, di ba meron kayong mga tawag nito, mga control box to tune the correct frequency. If you tune to correct frequency, what will happen? Di ba doon sa ACP ninyo, sa ACP, nahati rin yun. Yung taas ng ACP ninyo, yung audio control panel ninyo, that pertains to communication. But doon sa lower half ng inyong ACP, that is particular to navigation. Tawag nito, station identifiers. So if you tune to a correct frequency, you can hear something like a oral signal. So, and of course, indicating that you tune the VOR system range between 108 to 117.95. So giving 200 channels in the VOR localizer mode of 50 kilohertz spacing. All right. So yan, ito yung mga ginagawa ng mga piloto. Kailangan nyo pa bang malaman to, or ibigay na natin? Ang ano lang naman natin dito, ang concern natin dito is maintenance on your display units or components. All right, so ito naman yung isa, di ba? So Kaya dalawa eh. Dalawa. Alright, so meron kang, yun na nga, VOR number 1 at saka VOR number 2. At alam mo na, yan, yung VOR number 2 is the green. Alright, so ganoon din, kaya dalawa yung display units ninyo. Normally, itong EHSI, yan yung normal display. But in cases maybe the EHSI fails, no worries, you still have your backup systems, standby system, which is your RMI, radio magnetic indicator. Alright, paano kung nag-ano tayo, full and arc. So pinindot mo yung full and arc, naging arc na siya, di ba? And then in the captain remote controller, you can adjust the course at saka yung inyong heading. Right, the course and heading. Alright, course saka heading. Yung heading, mga kapatid, is common to both captain and FO. Kaya kayo, may heading kayo. Alright, and the course is independent because captain and FO has their own course controller. So course 1, captain, course 2 is your FO. Alright, so ganito yung sistema niya. Paano nag-work? So, example, VOR number 2. Alright, so in the VOR number 2, anong gagawin natin? You need to tune the frequency. So, you have your knob control box. In the knob control box, di ba, you can select it and then pupunta siya sa standby course window. Anong mangyayari ngayon? This triple toggle switch position, place it to transfer. What will happen? That the frequency will now go to active position. So magiging active na siya. Yeah, so the VOR number 2, receivers are independent. Alright, are independent but use a common top antenna or in the vertical stabilizer. Kaya nga ang tawag sa kanya doon is Vorlock. Ayan, Vorlock. So meron kayong receiver number 1, we have your receiver number 2. So you can tune their dedicated frequency by their own dedicated knob control unit. Alright. So yan. So pwede niyang i-tune. Pero they share a common Vorlock antenna which is located in the stabilizer. So each receiver controlled by a associated knob control box on the glare shield. So the audio signal transmitted to the remote control audio unit RCAU para marinig mo yung generation ng sound niya. Alright. And then the normal operation, the knob system 1 sends data to your symbol generator number 1, and that is also true for your receiver number 2 para doon sa symbol generator number 2 rin ninyo. Alright, so example kanina, you tune the frequency of system number 1. It sends to your VOR receiver ILS marker transceiver and sent to your SGU. It will be processed, and you see now this one sends now a signal to your display unit on the FO. But as you can see, it's not only in your display unit, but you can see in this one there is an analog signal that will send the information to your RMI. To your RMI. So dalawa yan. Kaya nga dalawa yung pipiliin mo rin dito, di ba? You can choose VOR number 1, ADF number 1 or VOR number 1. So if in case this one, so since you are choosing the number 2, so you have the VOR number 2 and your ADF number 2. Ayan. So So, pwede rin bang mag-tune ng frequency doon sa unit number 1? Yes, pwede rin. Yeah, pwede rin. So, you can select the frequency and then it sends to your transceiver and then it sends to your SGU. After the SGU, then meron kayong information dun sa captain side naman. But not only that, you see, same, it sends an analog signal to your number 1 and to your number 2 system of your RMI. So ano naman ang i-ano niya? Since number 1, ito naman yung ipupukol niya. Yeah. Meron kayong number 1 system. Yung number 1 system ninyo is located on the left-hand side. The number 2 system is located on the right-hand side of your RNP, radio magnetic information. All right, so yan. Nav captain and FO can be performed through your ASCB, multi-directional by means of captain. Yun na nga yung binabanggit natin kanina, di ba? Example, nasira yung system number 1. Nasira yung captain. So ano mangyayari ngayon? Iilaw ngayon yung system number 2. Captain number 2. Parang ganun. Diba? So pipindutin mo siya ngayon. So walang problema kasi yung information dito can be, say, sa example, nasira to. Merong interconnection between the two, diba? Yung parallel reversion bus. Ngayon, paano naman kung nasira yung symbol generator? Walang problema. Diba? You also have ito kasi ang pinapakita dito sa inyo is the BUR ILS. So it means to say it's the transceiver. But how about the symbol generator? Nakita nyo na rin kanina, di ba? Meron kayong switching, di ba? At doon sa switching ninyo, meron kayong tatlo. Alright. That you need to switch. In cases maybe because of the redundancy of your system. So in this configuration, walang problema, masira yung BUR transceiver number ko. I still have the number 2. Alright, I still have the number 2. So anong mangyayari ngayon? Maybe this one fails. So paano? Alright, the BUR number 2 through your symbol generator number 2. Alright, so ganyan siya. So iba naman yung isa kanina. Paano kung nasira naman yung symbol generator mo? So wala na rin yan. Can I have the display unit to my captain? Yes. Paano? Through through the other side. Anong gagawin niya? Yung symbol generator naman, yung pipindutin niya. Nakuha? So I hope nakuha niyo yan, mga kapatid. So anyway, sa practical natin yan, talagang kakalikutin talaga natin yung aircraft nyo. Pero wag nating sisirain. Di ba? Huwag nating sisirain. Something like that. Yan. System 1 yung isa, FO yung isa. So kahit nasira yung isang transceiver, walang problema. Para siyang slave to the other, So for this example, nasira yung isa. Either VOR system number 1 or system number 2. Walang problema. Yan. So kita nyo dito. So priority is given to the captain in switching action. When the captain uses system 2, the first officer cannot use the system number 1. Alright, so ito, wag na natin ito kasi this is an interpretation of how the VOR works. So ang lang natin, ang concern natin is the system. Ito kasi is ginagawa ng mga piloto. So alam na alam ni Captain Romer to. Ayan. Siya na yung mag-interpret niyan. Hindi na tayo mag-i-interpret niyan. Alright, so knob control box is used to select ang inyong frequency. Alright. So pag titignan nyo ngayon, ano yung laman niya mga kapatid? Yan o, viewer, ILS marker. So viewer, ILS, and marker. So it's the viewer and ILS frequency. Okay, so in the vertical stabilizer, you have a common antenna that we call as the VOR localizer antenna. Right, is made up of two blades. All right, two blades. Both blades are located on either side on the vertical stabilizer, and of course inside you have the coaxial cable between both sides. Is an essential factor of antenna tuning circuit. So grounding is made. Nakikita nyo pa ako mga sirs? Nagluloko yung ano ko. Anyway, we are almost done with this one, and we can have our break, dinner break. So that is your wall lock antenna. Ayan, so ito yung connections natin. The coaxial cable, and from the coaxial cables, they will be separated, and the other one is connected to transceiver number 1, and the other one is connected to transceiver number 2. All right. This transceiver, gentlemen, is located in the specifics 83 and 82 VU. All right. Okay. So these are the specifics of our systems. And I think this one has been discussed before. So you have your frequency, you tune this one, and then after that, you place this toggle switch to transfer position to make it active. All right, and the locations of your control box, knob control box, is located in the glare shield. All right, just adjacent to your AFCS control panel and the advisory display unit. Okay. So any question, guys, relating to your VOR system? All right. So if none, mga sirs, so I think we need to have a break now, di ba? And please be back at around 7:06 to make it exactly. All right. So see you then, gentlemen, and we will continue after dinner. All right. See you then.
Thank you, sir.
Thank you,
Okay.
sir. Thank you po. Thank you, sir.
Yes, sir. All right. Good evening. Good evening. So this is the second set of our topic. Yes, sir. Sir Alan. Okay. So to begin with, of course, our next topic is our DME. All right, DME, or the distance measuring equipment. So this is an independent position determining system, meaning it has its own system sending pulses of signal, and that is something like focuses on the slant range. All right, slant range. So this the distance measuring equipment has to be processed by a different component like your symbol generator, including your AFCS computer and the global navigation satellite system, and displayed it on your AHSI in front of its pilot. All right, so you have your DME. All right, so it's a medium range navigation aid operating in the 1025 to 1150 megahertz, ranging with 1 megahertz spacing. It indicates a slant. Please take note, gentlemen, your DME is a slant distance of the aircraft from a selected station. So your DME, just like I mentioned earlier, it also computes your ground speed and the time to go. All right, so which are selectable in the ground speed time to go post button in the EP's control panel. So that's why we have the time to go. And you see that one, gentlemen? All right, you have the informations regarding our DME. Normally, your DME is collocated with your VOR instrument. You see this one now? The VOR and the DME station. So if you see the VOR and you see the display or the distance, I mean, that is, of course, that is your DME. All right, so this is the concept or the architecture of your DME system. So the DME has two antenna, the DME1 and your DME2, and you have also your DME interrogators. So we have your transceivers DME1, DME2 and DME1, and of course you have the DME control units in which you can tune the desired frequency. Actually, if you tune the VOR, you also tune most likely the DME because they are actually co-located. So this distance received, of course, via your antenna, it sends now to your DME transceivers or interrogators. And of course, from there, it will be processed through your symbol generator system or the symbol generator unit. All right, and transferred, you see now this one, digital bus, and then transferred through ASCB. So this is digital bus, but the communication between the SGU1 and your SGU number 2 is through a two-way communication called your ASCB. All right. And of course, DME channeling is accomplished either DME1 or NAB1 or NAB2. So that's why you have your control unit NAB1 or NAB2. And see this one, the DME interrogators also, once it is tuned to a correct frequency, it gives you the station identifier audio signal to the RCAU. That's why from the DME transceiver, it goes to your RCAU to produce your station identifiers. Now, these DME interrogators, gentlemen, is also connected to your ATC and TCAS. Why, gentlemen? Because most likely the frequency of your DME is also within the frequency range of your ATC as well as TCAS. So if that's the case, this system, gentlemen, your DME, ATC, and TCAS are interconnected via a coaxial, suppressor coaxial, to avoid simultaneous transmission. So then the indications now from the symbol generator, they are now being displayed in your EHSI captain as well as in your EHSI FO. So it can be full, it can be arc, or it can be in the composite mode. All right, so for DME number 1, gentlemen, this is powered by your normal DC number 1, and your DME number 2 is supplied, powered by your 28 DC bus number 2. All right, so this is how it looks like, your suppressor. So since the 3 components, gentlemen, navigational components, your DME, your ATC, and TCAS are of the same frequency range, they are connected to a suppressor coaxial to avoid simultaneous transmission and reception. All right, now there is no integrated self-test in the DME. It can check according to the following procedure. So normally, this one, gentlemen, you have the navigation control box. And then if you press the test post button, so what will happen? It goes to self-test diagnostic routine. All right. And after the self-test, takes approximately 10 seconds only to complete. And after a few seconds, after pressing the test button, a numeric display shows test distance of 100 nautical miles. All right, that is the what do you call this one? The test distance of 100 nautical miles, and the DME oral code will be A-OK. All right. So then we have also this one in EPIS control panel. If you press the ground speed, the test will show also 100 knots. So simultaneously with the TTG, if you press again the ground speed and the TTG push button, the test will also show 60 nautical miles. All right. So the distance is 100 nautical miles. The ground speed is 100 knots, and the time to go is 60 nautical miles. So completion of the test indicated when normal, all the display returns to normal if there is no faulty in the system. Because if there is fault, so most likely in the display unit you can get some fault codes. All right. So this is now your DME and your ATC. So most likely actually they are identical as the note says, and as per our experience, if you see them, they are actually identical and connected. It's interrogator by means of a 50 ohms coaxial cable with PTFE insulations. All right, and of course you have your DME antenna, DME1 and the DME2. So it's something like they are in a longitudinal way, longitudinal cross sections of the aircraft on under the belly, just adjacent to your nose wheel How about the ATC? Actually, the ATC is located on top. Actually, you have two antenna for ATC. You have the antenna top and the antenna bottom. For the DME, you have only two antenna because that is dedicated to your DME transceiver 1 and 2, respectively. All right, so this is how it looks like, gentlemen, along the x-axis, just adjacent to the nose wheel landing gear. You have the two antenna, DME1 as well as your DME number 2. All right. So these are the frequencies of your DME. For transmission, you have 1025 to 1150 megahertz. That is transmission, and reception is 962 to 1213 megahertz reception. So your DME can simultaneously track and provide complete information up to 3 DME stations. All right, so and of course the data is displayed in the EHSI. So 2 channels of DME can be used by the navigation processor unit for the GNSS. So perform the DME navigation in case of satellite loss. So you still have that one. That conforms to something like a triangulation process for you to determine the position of the aircraft. So we have also the DME audio signal sent to the RCAU, and the volume can be adjusted through your audio. So remember, gentlemen, so in your ACP, there are 2 sections. The upper section that is used for all right, communication, but on the lower portion, this conforms to your audio for navigation system. All right, that's why we have DME1 and DME2 in order for you to determine if you tune to a correct frequency, you can hear a DME audio signal. All right, so where can we find the DME transceiver? The DME transceiver is located within the electronics rack on 8PBU, specifically on your 83 and 84 PU. All right, so how the system works, of course, you need to tune the DME, the DME through your navigation control box. All right. So DME can be put on hold by selecting the hold position and the mode switch. So you have the hold. So, but normally, of course, you have to set it to on, and then you rotate this knob, and it will be placed to your standby course window, and then you place the toggle switch to transfer pause button, and it will goes to active window. All right. So this knob frequency in the upper window can be changed during the time DME hold is selected. So during DME hold, the present or the preset frequency that has been displayed in the lower window prior to DME hold is hidden but remains in the preset memory. So it means to say it goes to the stored, it will be stored in its memory. All right, but when the DME is in the hold mode, the amber H on top of the right corner of the affected EHSI. That's why you have this one, hold, DME hold. All right, so we have your 2 control box to tune the DME frequency. All right, which are located in the glare shield. So the aircraft is okay. So aside from the DME, guys, we have also another homing device. Actually, we have 2 types of homing device. The first one that we discussed earlier is VOR. The second one is your ADF. The VOR, gentlemen, is pertaining to the north, from the north 360 degrees. Right? That's the basis of our VOR system. But how about for the ADF? The ADF is provides relative bearing indication to a selected NDB station or broadcasting station. So meaning to say, it depends on the heading of the aircraft towards a particular non-directional beacon or your ground station. So, and that angular displacement, that is the locations now of your non-directional beacon. All right. So the system provides also oral to allow the NDB identification. So just like in the, what do you call this one? Can I clear this one? All right. You have also your NDB. All right. In the audio control panel, your ACP, you have also ADF1 and your ADF number 2. All right. So see this one, gentlemen, if you want to hear some broadcasting station, you can actually tune through your ADF. You can find the broadcasting station or AM station. All right. So this is the system, gentlemen. So you have your navigation sensors, your antenna. All right. And since we have the ADF, it can be tuned, it can be selected through your ACP. So selection of either ADF1 or ADF2, it goes to your symbol generator unit, and from the symbol generator unit through its dedicated video bus sends the information towards your dedicated EHSI. All right, so you can see that depending on the selection, you can find the bearing, two bearing information. So you have the circular, or the what do you call this one, the diamond shape, right, which can be selected through your EP's control panel, and see there is also an interface through your RMI. All right, the RMI number 1, captain, is connected to your symbol generator number 1, but the RMI number 2 is actually connected to your symbol generator number 2 via your HSRU. All right, so yeah, this is your simplified diagram. So we have a 2 antenna, all right, 2 antenna, and the 2 receivers, and from there, of course, you have your ADF control units, right? And you see it's connected to your RMI, all right, and of course 2 ADF transceiver. So whenever it may be, if you tune to a correct frequency using your ADF control panel, all right, control panel, the ADF will receive or transmit, all right, transmit that signal, and of course it will be received by the ADF, all right, if you tune to a correct frequency through your ADF adapter. And then of course that signal that transmits or receives will be processed, of course, through your symbol generator unit, and the symbol generator unit now sends the information to your related EHSI. All right, so how about if the display unit fails? Oh, no worries, that's why you have your RMI as a backup to your normal system in case of faulty considerations. All right. So your ADF number 1 is standby bus, but your ADF number 2 is main bus. And of course, if you tune to a correct frequency, you can hear something like an audio reception signifying that you tune to a correct frequency. So example, if you tune to a AM station, so you can hear those AM stations. All right. What else? All right. So this ADF system is composed of two subsystems: ADF1 captain, ADF2 first officer, and that's the thing now. The ADF information is sent to your EHSI via your symbol generator, but of course, it can also be forwarded to your RMI as a backup system, system indications. All right, so yeah, it can also be displayed on the EHSI through the SGU depending on the selection in your control panel. So you can select, so actually in your ACP or in the EPIS control panel, you can select this is the system number 1 and system number 2. System number 1 and system number 2. So whatever may be, so you can select VOR1 or VOR2 and it gives you something like a different identity. Right? The other one, the bearing information represents circular in different colors. That is also same as well to your bearing number 2, which is diamond in shape. Right. And that is also, yeah, it can be in your RMI as a backup to the system. And of course, normal consideration is displayed in your captain and first officer EHSI through your symbol generator. All right. All right, so frequency range of 190 to 1749.5 kilohertz. All right, so yeah, you can see the ADF in the RMI. You can select actually VOR ADF1 and your ADF number 2. Okay, you can actually select the pointer. So yeah, you can see this one. The bearing information for number 1 system is yellow. But so it means to say this is your number 1 system. And your number 2 system is the green. All right. And that is also true. So example for system number 1, ADF, and the ADF number 2 as selected, the bearing information is circle. So that is your ADF number 1. But if you select also ADF number 2, that is your diamond. So that is your ADF number 2. So this is diamond, the number 2 system, and the number 1 system is circular. All right. Pointing towards ADF station. So these are homing device pointing towards a particular station. All right, so selection, gentlemen. So that's the thing. I think we've shown this one. So you can select your ADF frequency. So you can tune by rotating this knob, and it will be presented in the standby window. So what to do? You place the toggle switch to transfer post button, and it will transfer to active window. All right. So yeah, this one you can select VOR1 or ADF1. And of course, you can tune the frequency. And what happened? The indicating system now will point towards a particular selected station. All right, example for VOR. So this yellow now is that is now your VOR, and the VOR number 2 is selected towards a particular station. So that is also true. See this one now, the green, that is your ADF1, and the blue, all right, or the yellow is pointing towards your VOR number 2. ADF, if you select it to ADF, then that yellow represents your ADF number 1. but the green is still presenting the VOR number 2. If you press the test post button, what happened? So, yeah, when the test post button is pressed, what happened? So the Captain ADF control unit, a yellow single pointer on the RMI and the blue pointer rotates all 90 degrees clockwise from previous validation indication. So it goes 90 degrees. So all the same time, you can hear a 100 tone of voice can be heard by setting the ADF mode selector to tone position. All right, so example for this one, if you select it to tone, so you can hear 1000 hertz tone of voice. All right. Okay, so we have also the test post button. Okay, if you press the test post button, what will happen? So the intensity display is modulated from maximum to indicated that the self-test is in progress. So if no faults is detected during the self-test, 4 dashes will be displayed on the upper window and the code is 00. So it means to say this is good. But if there is something like failure, you can find the word diag and the full code, which is 07. So you go to your FCOM and look for full code number 7 and what is the faulty configuration of your ADF system, the input output port 2 failure. So you need to do some troubleshooting. All right, so you see, it can give you full code and at least you have the FCOM easy to find. All right, so you have 2 ADF antenna. All right, so ADF antenna are located in the aircraft center line. All right, so bonding is ensured by means of a conductive antenna gasket. So you have 2 antenna. The ADF antenna number 1 is located on top, and the ADF number 2 is located on the bottom fuselage of the aircraft. And your ADF is most likely located, of course, in the avionics compartment. So you have the 1 and 2 transceiver operate 190 to 1749.5 megahertz. All right. And they are located in 80 VU, specifically 81 and 84 VU. For ADF transceiver or receiver number 1 is on the 81 VU, but for the ADF number 2, it's located in 84 VU. All right. So this is the system. I think this one has been presented earlier. So the ADF number 1 is supplied coming from your standby bus. All right. But for the receiver number 2, it's normal bus. So in case of emergency, maybe you can lose the ADF number 2, but it's still the ADF number 1 is still working. All right. So ADF 1, ADF 2. Adapters. So you have also the adapters. So the adapters 1 and 2 is located in 81 BU. So see this one, you have the adapters. Yes, you have the transceivers, but you have also your adapters used to connect the digital ADF control units to analog ADF receiver. So it means to say it's just a converter of from analog to digital. All right. So we have two adapters also, adapters number 1 and adapters number 2. So the supply also, adapter number 1 is supplied by standby bus, and adapter number 2 is supplied by main bus number 2. Okay, so this is again the same configuration, gentlemen. So you can place, or you can choose the frequency of your ADF. Right, and after that tuning, you place the transfer switch to transfer, and it becomes active. All right. Your ADF control box is or control unit is located in the center pedestal. All right. Same, your ADF control box is also supplied by your standby bus. All right, so you have the standby bus, so supplies your transceiver, supplies your adapters, and also supplies your control unit. So that is also same with your main bus, to supply your adapter and to supply your control units, and of course your transceiver. All right, so that is your DME and your ADF. All right. So is there any question, guys? So if you have, then don't hesitate to raise your questions. Okay, now we go to your GNSS. We still have a lot of things to discuss for your navigation system. Anyways, so let's go to GNSS. All right, so the aircraft is, although the aircraft is flying in a short range, still your ATR is still equipped with satellite system called the GNSS. In the DAS 600, it is now what do you call this one? Supplemented by GPS. So for the DAS 500, we call it as a global navigation satellite system, but for the DAS 600, we called it as GPS. So using information provided by the 24 constellation, 24 satellites constellation, able to track the up to 12 satellites at a time. The GNSS automatic tri-dimensional to give you your latitude, the longitude, and the altitude. All right, so it gives you the location. It's not only the location, but even your present position. So locations and navigation means, so it's a 3 different zones of database are available in your GNSS. All right, so GPS can give 3-dimensional position measurement accurate within 50 feet. All right, so the what they call this one, the radius of satellite is up to 50 feet. That's why no wonder the radius is 50 feet. For the 320, it's 100 feet radius. So differential global positioning system is not yet fitted in the ATR. So and it gives navigational accuracy of 1.5 meters vertical and 1.5 horizontally. Your DGPS is much more reliable than GNSS, but most likely the principle of operations between these two different types of GPS, the GNSS and the DGPS, is still the same. Just like I've said in the DAS 600, it's no longer GNSS but GPS. All right. So for tracking purposes, so provides a full flight navigation system that performs navigation and route planning. So it means to say it's nothing to worry about navigation if you have your GPS. So it reduces the workload. All right, it reduces the workload for route planning, navigation, aircraft guidance, monitoring of flight progresses. And the pilot define the route from the origin to destination by data entry in your MCDU. All right, so during flight guidance function, compares the aircraft actual position and the desired flight plan and generate the steering command to the autopilot. See, so it means to say an input coming from your autopilot system. It goes to your AF flight data acquisition, what do you call this one? The auto flight system, your auto flight system, and this auto flight system now will command those actuators to follow or to steer the aircraft towards a given actual position. All right, so it directs also, provides the aircraft present position to any flight plan and waypoint. That's why you can track it through your navigational display. All right. So you have the point of origin, and then as you take off, climb, cruise, descend, approach, and go around, to include also even the go around. All right. All right. So you have your system here. So your GNSS interface with several navigational components. So you have your navigation processor unit. We have the MCDU for the pilots to enter those flight routes. We have your GPS antenna. All right, we have a single GPS antenna. We have the configuration module and an optional data loader. All right, so your GPS is a omnidirectional antenna which is installed on top of the aircraft fuselage and receive, amplifies, and condition signal of all GPS satellites in view. So at least a total of among the 24 satellites, it can track up to 12 satellites. So this antenna transmit the signal to the DPS transceiver in the NPU. So it means to say from your antenna, it receives signals coming from your, or track a signal coming from your satellite system and send that signal to your NPU. All right. Okay, and then the NPU now process and contains the GPS receiver, computer navigation database, and requires external system interfaces. So that is the heart of our satellite system. Airborne satellite system is your navigation processor unit. All right, and then, oops. And then the NPU receive the global navigation system and the flight management system from the GPS antenna and other aircraft systems. All right, so for example, your ADC. So you have your ADC, your air data computers. You have two air data computers. It can be selected either air data number 1 or air data number 2. So it depends on the date. So example, today is 7, so most likely it's ADC number 1 that provides you the air data data. All right, air data. So compute position and course information, and then it processes and codes the information for the output of the MCDU and to the equipment such as your autopilot and your EHSIM. That's why See this one from the NPU. It sends a signal to your AFCS computer to give the steering command to follow a given flight route as choice in the MCDU, as the pilot chooses in the MCDU. It sends a signal to the NPU, and the NPU sends signal to your AFCS computer for steering command. All right, so this MCDU is an interface between the pilot and the GNSS. So it is used to enter, monitor, and revise route, to display information, and to select operational mode. So it's in the MCDU. So it provides straight out capability along the verification of the data entered in the memory. The route advisory data are continuously available for display in the MCDU. That's why you can actually revise that also. And the MCDU provides the full alphanumeric keyboard plus function of the line select keys. And then you have the configuration module. What is all about your configuration module? It stores the setup information about the aircraft. And of course, you have the optional data loader. Is used to update the software of your system. All right, and then now, how about this one, gentlemen? How about if you lose your GPS sensor? So in case where the GPS position becomes unavailable, you have your backup navigation system that conforms to your DME mode. So if the radio coverage allows it, that's why normally the aircraft, since this aircraft is inter-island, so most likely it cannot just passes through wide body of water or mountainous area or desert. Because if that's the case, most likely if you lose the GPS antenna, there is no such thing like DME stations on those environment. So most likely the aircraft is just flying within a designated areas wherein, in case you lose your GPS, you still have a backup for your navigation system called the DME mode. So if not, the dead reckoning now is used to back up utilizing the true airspeed, the heading, and the last computed wind data. You still have, but in some instances, maybe some of the pilots now may be so accustomed with the use of the GPS antenna. I remember when we were still in A+, if the pilots keep on asking if the GPS is okay. If the GPS is okay, most likely those pilots may sometimes they are requesting replacement. All right, replaced by somebody, because these pilots are not so accustomed with the traditional mode of navigation. They want an easy way using the GPS system. All right. So for navigation, so you can find those most likely in the APs by pushing the map post button in the ECB. Then you can now see the multiple waypoints shown in the EHSI. All right. The nav source annunciators also identifies the source which supplies the EHSI. So example, nav source identifier, that is RNAV. All right. And then you can see also some figures depicting the VOR station, something like that, RNAV waypoints, airports, and yeah, even the RNAV stations. And for the MCDU, so maintenance data is available via MCDU for troubleshooting purposes. So no periodic maintenance or calibration is required on the system. So system maintenance is performed on a unconditioned basis only. So what is that unconditioned? If something like faulty, then you do the maintenance. If there is no trouble on the GPS system, then most likely no maintenance. but much better. You see this one, each component comprising this HD1000 system is continually tested utilizing the built-in test equipment when the system is in operation. So it's continuous, all right, as long as it is powered. So when the system status change or a fault occurs within the system, the message annunciators on the MCDU illuminates and a message is displayed in the scratch pad. So this is the, what do you call this one? Scratch pads of your MCDU, the lower portion of the display unit. All right, so this maintenance data is accessible through your data index page by selecting maintenance. So if you select that one, what will happen? So you have now the maintenance index, and you can see now the configuration, the byte history, the return to service, and the interface check. And of course, message recall. Okay, so example for configuration. Yeah, you can find now configuration ID, that is your ATR 72-500. All right, so you can find also the tail number, the nose number, and the side number. All right, so from time to time, you can have also this one. Note that the configuration identifiers, last letter gives the configuration origin. So if you can see, M indicates the origin reconfigured via manual entry. But if you can see the P, the origin configuration programmed via data loader. So that's why you can see this one, the P. All right, through data loader. So let's go to review config. All right. So allows review of the configuration of the aircraft and insert the turn number, the nose number, and the side into the configuration module memory. So you can see now the identification of your aircraft. Not only the identification, but the series, of course, and also the engine. So, and then exit. All right. So you go to, all right. Okay, next is the byte history. Right, by pressing the available line select key example, the operator can get more details of failure. So example for this one, indicated airspeed input fail. So that was happened last 17 June 2001. Real-time clock fail last 22 May 2001. And also indicated airspeed also input fail last 4 May. So those are the things you can recover all those recorded in its non-volatile memory. So all stored failure can be erased by pressing the erase all. So in the line select key, right, 6 right line select key. So if you press that one, so as long as they are being what do you call this one, done already, the maintenance task has been done, then it can be erased. So after the configuration and the byte history, of course, you have also your maintenance or the return to service and interface check. All right, so return to service. So the tests run are CRC check. All right. The test of each processor availability to read, write, and correct address of all from verification of proper execution of match scope processor, verification of all interface processor communication link, and testing to verify all system inputs and output function. And of course, you need to wait for quite some time because it takes some time to do the test of your system. All right, so and lastly, you have the interface checks. All right, adjacent can be displayed through CDU. So selections under discretes, selection under autopilot, selection under CDI deflection, selections under to from. So those are the things. And you have also in the right columns, the output based on the configuration module for synchronization or synchros. So selection under its synchros includes 000 to 330 in the 30 degrees increment. All right, so let's check for the maintenance index. Message recall. So this display all the current messages. Okay, so that is your GNSS, gentlemen. So at least for proper positioning and indication, precise indication is specifically for your latitude, longitude, and altitude. We have your GNSS. So where are stored GNSS aircraft data? So saan ba? Of course, you have in the configuration module, which is directly interfaced in the NPU. So we have your antenna, gentlemen, located on top of the fuselage. So you have one antenna coupler unit and one multi-directional antenna. So this GPS antenna is an omnidirectional antenna which receives, amplifies condition signal from orbiting satellites. And how many satellites? You have 24, but it can track up to 12 satellites. All right. So yeah, we have the GPS antenna and send that signal to your NPU and it will be processed. So antenna is located on the top fuselage, upper part fuselage of the aircraft. The NPU comprises 12 channel, processor card, and input-output. So what is the purpose of the NPU function? Central processing, GPS positioning, database storage, data processing, input-output processing through your MCBU, autopilot, air data computers, and AHRS. All right, so the connector is fitted in front of the NPU to allow. So you have now this one. Allow connections of the data loader in order to update the database. But updating your database, it can only be done on ground, available on ground only. All right, so these are the other interface of the system. So aside only from the GPS antenna, you have the ADC computer, the weight on wheels. That's why updating of your nav of your database through your NPU is only on ground. So you have also an information coming from the compass, the configuration modules, your fuel flow indicator, the go around the MCDU, and the DME for distance informations. And of course, to supply the electrical operations of your GNSS is supplied by the DC, standby bus number 2, and also your standby bus in case of emergency. All right, so your NPU, navigation processor unit, is located in 80VU, specifically 84VU. All right, so we have also your MCDU. So this is the features of your MCDU. You have your alphanumeric keyboard. You have also a lot of functional keys, including the line select keys and the annunciators, and to display the brightness. That's why you have that one, bright dim. And of course, you have the 5.5 inches screen that contains 14 lines with 24 characters per line. And what is the purpose of our MCDU? So entering, monitoring, and revision of flight plans, display of information, selection of operational modes, and reading and checking of your data entry entered into the memory. All right, so a lot of things, gentlemen, that can be done through your MCDU. So entering those waypoints, courses, and distance. So information entered in the MCDU is transmitted to the NPU for processing. So it's just vice versa from the NPU, yeah. And from the MCDU goes back to your NPU. So enter the NPU output, the process information back to the MCDU for display. All right. In some other cases, gentlemen, MCDU only one, but in the DAS 600, for the DAS 500, maybe one, but for the DAS 600, they have two MCDU. So meaning, gentlemen, it's an option. It can be one, it can be two, or it can be more depending on the options of the operator. All right, and you can see now the configuration module that stores the information about the aircraft. So it's it has a one microcontroller, and the ATR configuration data is stored in a non-volatile static RAM. So this configuration module stores the aircraft installation data, controls access to the aircraft installation and configuration data. All right. So can only be modified on ground. So at power up, the NPU compares the configuration with one of the received from the configuration module, and of course looks itself if a mismatch is detected. So this configuration module is powered through your NPU with 5 volts DC. All right. So note that the data stored in the configuration module is normally recorded by the ATR for new aircraft, but you see this one, or has to be introduced by the operator in case of retrofit or new modules. So it may be possible to use the NPU of another aircraft with the same configuration. So minor changes na lang siya. All right. So the configuration module is just adjacent to the NPU. All right. That's the configuration. What do you call this one? The data loader. I mean, loading the navigation database from Honeywell. So it has two functions: load software updates and to load or save configuration data. So most likely, what is this one? We normally update our nav database every how many hours? Okay, so it can be coming from the NPU also. You have the maintenance port for updating, but if not, you have the data, what do you call this one? Your data module or data loader will automatically detect the card type and provide the appropriate options available for this card. So pressing the mode, you have this one, 3 post button keys. All right. Mode key will cycle the available options, and pressing the execute key will execute the display option. All right, so these are something like an example of loaded information to the system via your MCU. So it has something like a meaning. So your HT2 is the region database, and then you have the 99 that is here, and then you have the 04 that is the cycle, and of course 01 is 001 is the edition. So so they have something like an identification. Yeah, so you see this one now, every 28 days, guys, you can update your NAV database every 28 days. About if you did not do it, you forgot to update, can you still dispatch their account? So as per MEL, yes, but most likely within 10 days, you need to update your NAV database. Okay. So that is your navigation system, or your GNSS, Global Navigation Satellite System. All right, so I think we deserve 10 minutes break, guys. So please be back at around 8:20. All right, 8:20, and then we start again another topic. Navigation system is very long. All right, see you then, 8:20.
Copy, sir.
All right. Did you study this one? When you were not? Not yet. That one. Again? No, you continue. Just you continue because we have also another, you just, continue, I need to check. One next. What is the next? See, next. 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 So you stand then. Okay. You press it. No, no. Give me.
Yellow, the stuff from inside here.
This one. Our answers for the following slide. Okay. Hmm? This is practical. So you need to set up. Let me give me the.
Can I send it to my alternate account? Can I send it to my alternate account?
Wait. About this one also. Florence County.
One question, did you eat already? Food?
Ito.
Meron ba? Sila na.
Ano mo lang.
Eh,
All right. So welcome back, gentlemen. So our almost done for this day. So our next topic, gentlemen, is your ATC. So for navigation system, of course, we need something like a transponder. And of course, we have three different types of transponder. We have the mode A, the mode C, or the mode S. But of course, as of this moment, of course, the ATR is not utilizing the mode A or the mode C, but of the mode S. Okay, so a total package for mode S. So we have the ATC is a dependent position determining system which process data for the air traffic controllers with altitude information provided through your air data computer. So we have your ATC transponder. So it gives you the identity, and not only the identification of a particular aircraft, but also the altitude. And since we are utilizing the mode S transponder, it also increases the surveillance of a particular aircraft. Right. So we have your, the ATC is dedicated to provide the air traffic controller with information. So requires the identity for tracking purposes. So the ground control sends an interrogation pulses, and the transponder of the aircraft replies by transmitting an encoded signal enabling the aircraft identification and the altitude to be known. So just like your flight radar 24, you can see those aircraft flying, but if you click a particular aircraft, it gives you added informations pertaining to the said aircraft. So yeah, see this one, gentlemen, the ATC that we are utilizing for ATR system is your mode S transponder. Allows air-to-air exchange data between TCAS equipped aircraft. So the ATC that we are utilizing is not only a communication or an interrogation between aircraft to ground station, but it can also be an air-to-air data exchange. So that's why one of the requirements of our TCAS system is a transponder. If you don't have transponder, there is no way to communicate other aircraft on flight. So the only way to communicate on this data to provide you the identification and the altitude is through your mode S transponder. So it can also be using your mode A or mode S, but the surveillance information is limited, unlike in your mode S. All right. So yeah, ATC system, of course, we have the ATC. So yes, as you can see, gentlemen, your ATC system comprises 4 antenna, 2 on top and 2 on the bottom. And just like we mentioned earlier, when we talk about the DME system, the ATC, and your TCAS is most likely tuned to within a frequency range. That's why they are equipped with suppressor coaxial to avoid the simultaneous transmission. All right, so why the system ATC is interfaced to ADC? Because the ADC pertains and gives you the information regarding the altitude of your aircraft. All right, so your ATC1 is emergency bus, and your ATC number 2 is most likely supplied by main bus number 2. All right, so same as well, gentlemen, they have the suppressor coaxial for the 3 navigation system, your DME, ATC, and TCAS. All right, so of course, you need also to tune the what do you call this one, your ATC. So the ATC is equipped with a self-test which activates by setting the mode selector from off to power the unit, and then by pressing the test post button on the control unit. So you can place it to off, standby, or on, or altitude. All right. So if you if the ATC transponder is functioning correctly, you can see the AL will be displayed in the upper window, and the actual altitude is displayed in thousands of feet with 100 feet increments in the lower window. So example, correct functioning properly, and you can see 2.1 or 2.1 feet or 2,100 feet. All right, so here's an altitude of 2,060 feet is indicated by 2.1. So it's 60 almost 1. So it's a round off to 1. So when the ATC test is initiated, the active display intensify the modulate from minimum to maximum the illumination of the display. All right, then if you press the test post button and there is fault in the system, then you can find the diag plus the fault code. So what is that 08? Transponder source ID changed from last frame. So this code will momentarily occurs when changing between transponder 1 and transponder 2. This considered normal. So that's why there's some instances. Sometimes we often do replacing the ATC1 to ATC2 interchange, something like that. So most likely it can give you that faulty condition, but most likely that is normal. All right, so for antenna located on top and bottom. All right, so this is the top antenna and the bottom antenna. So they are just adjacent also to your DME antenna. And of course, your ATC transponder, yeah, you see now this one, guys, you have different types of modes. So in some other cases, if you use the mode A, it can only give you the aircraft identification and location. If you use the mode C, you have the aircraft identification, location, and the uncorrected barometric altitude. But if you have the mode S, it replies to selective calling also from ground-based radar and suitable for TCAS system. This mode S now replies, includes all information supplies by mode A and mode C, plus a unique aircraft identifier. So meaning to say, gentlemen, if you are utilizing the mode S transponder, it's not only the basic information, but to increase the surveillance of a particular system. So the mode S transponder provides capability for digital data link between aircraft and ground station and aircraft to aircraft. So it also enhances the operation of TCAS, ATC, and ATC communication. So your ATC interrogation signal is sent to 1030 megahertz and they reply at 1090 megahertz frequency. So you have two ATC transponder, which is also located in 80 BU, specifically 84 and 85 BU. All right, so same thing, gentlemen. You have the ATC control unit selection for active codes on which transponder to be used. So on the upper part of the page, the upper display window showing the active codes on which transponder is tuned. And in the lower window, it shows you the ID level by pressing the ident post button. All right. So both windows are also used together to display the aircraft current altitude during self-test and the diagnostic diag message plus the codes during self-test. All right, so two types of annunciators. You can see the active and transfer. So active illuminates amber during code changes. It flashes when the actual reply code is not identical to the code shown in the active display. And you have also the TX illuminates amber when the ATC reply to interrogations. All right, and then you have 1 and 2 position switch. So of course you need to select either ATC 1 or ATC number 2. All right, and then of course in the control unit, of course you have a different position. Normally you can see off, so the transponder is de-energized. You have also standby. System is underpowered, does not transmit replies. You have also on. Transponder replies to both mode A and mode C interrogations, but without level flight information. But if you have in the alt position, the system information operating position replies to flight level information. And then of course you have the SWAC code now, the outer nub and the inner nub. And of course you have to select the range of 0000 to 7777. For emergency code, that is 7700 and 7600. And the display flash code for approximately 5 seconds before sending the code. So in case of hijacking, something like that, they rotate this knob and enter the SWAC code. Right. So we have also the ident post button, which is used to transmit the special identification pattern that requires to swap ident by the air traffic control. ID letters are displayed under the active codes if you press the ident. And then you have also the test post button, initiate self-test. All right, and then you have also the pre, all right, the preset, pushing and holding the pre-post button, turning the code select knob, allowing the selection of the code for storage. So that's why you have also stored code inside the control box. And of course, we have the light sensors that automatically adapt to the brightness within the cockpit environment. So you have your ATC control unit or box, which is located in the center pedestal. All right. Oh, that is your ATC, small topic only, gentlemen. All right, ATC. All right, next topic is the TCAS now. One of the requirements, gentlemen, of your TCAS in order for the computer to know who are these potential threat is your ATC. Without ATC, of course, you cannot see a particular aircraft within the surrounding. So it's a requirement. It's a requirement to have this ATC transponder in order the TCAS to work. All right. So we have the TCAS 2. Right, regulation may vary for a certain countries. I think in the Philippines, it also requires the TCAS version 2. All right, so your traffic alert and collision avoidance system is a family of airborne device that provides collision avoidance for a wide range of aircraft types. So you can, even though maybe it's different types, but just like we mentioned earlier, as long as you have this, what you call the ATC transponder, they can see you. It can establish a interrogation between aircraft to aircraft. All right, aircraft to aircraft. All right, so before you have the TCAS 1 provides traffic advisory. All right, the traffic advisory, but now you have also the TCAS 2 now provides advisories and resolution advisories. But of course, there is a TCAS 2 version 7 that has been available from the beginning of 1999. And that version 7 improves the TCAS compatibility with air traffic control systems. The most significant enhancement are the introduction of your RBSM, all right, the reduced vertical separation minima. All right, but most likely, since RBSM, it may not be applicable for ATR because the maximum ceiling of your ATR is only up to 25,000 feet. At the RBSM is 29 to 41,000. Anyways, that can still be usable for tracking aircraft and at least you know the vertical separation between aircrafts. All right, so yeah, we have now the TCAS 3. So it gives you same advisories as the TCAS 2. However, It gives you also resolution advisories, provides the horizontal maneuver. So before, it can only give you the vertical maneuver, all right? But now it can also give you the horizontal maneuver. All right. So we have your airborne collision avoidance system, 1, 2, 3, same standard with TCAS. Your ACAS is American, whereas the TCAS is IKO, something like that. So no ACAS 3 equipped currently exists, and none is likely to appear in the near future because of the technical and operational difficulties. So as of now, you have the TCAS 2 version 7. And that is enough for this moment. So for the TCAS, the information, gentlemen, is integrated in your vertical speed indicator. All right. It's indicated in the vertical speed indicator. So in respect to this reply to the flight path of other aircraft, it determines potential threats. So what are these, what you call potential threats? So we have 4 potential threats. We have the other traffic, proximate traffic, traffic advisory, and the resolution advisory. And that can be presented in different symbols. So that symbols, not only the symbols, but even something like any other information depicting an aircraft if the aircraft is going up or going down with a certain altitude. All right, so depending on the potential threat, the system provides traffic advisories, alerts, and vertical maneuvers resolution called the resolution advisories in order to avoid collision. But it's not only vertical, all right, the vertical maneuver now, but just like it mentions, there is a provisions now in this new technologically advanced TCAS to have also horizontal maneuver resolution. All right, so yeah, these are the alerts now generated by the TCAS, and I think it has been discussed previously that the sounds generated by TCAS, the GPWS are preset. They are preset. So there is no control of volumes. All right. So not only alerts, oral alerts, but to give you visual warning. So as you can see, this is now the vertical speed. And you can see now a color red square with a negative 0.1 indication. So what does it mean? So just nearby your aircraft, you have a at least 100 feet, and the aircraft is below your aircraft 100 feet. So it means to say don't go down, but rather climb. And this needle supposedly indicates to the green. It points to the green. It means to say you need to go up approximately 1.5 up to 2 feet per minute, something like that. 1.5 to 2,000 feet per minute. All right. Okay, so these are the different potential threats. So just like we mentioned, as per the notes, we have the other traffic, proximate traffic, traffic advisory, and your resolution advisory. So at least the impact of the aircraft, if there is no action from the crew, is from the other traffic, a maximum range of 12 nautical miles. For the approximate traffic, at least within 6 nautical miles. But if the aircraft is within the traffic advisory or in the resolution advisory, the distance between the aircraft can only be within 35 to 45 seconds for the traffic advisory, or 20 to 40 seconds impact if you don't follow the advisories as generated by the system. All right, so on-air cap is assumed to occupy volume. All right, so you are occupying a particular volume. So it depends on the airspace now. Maybe 1 air caps or 2 air caps. Actually, I think it's it can record up to 8 air caps. The most potential threat air caps can be shown in your display unit. All right, that is the other. As soon as these intruders enter this volume, the system provides only a visual warning to the pilot to help him to locate the intruder. So visual only, that can be shown in the VSI. But if the aircraft penetrates, enters to your approximate advisory, so same visual warning to the pilot. But as soon as it enters your traffic advisory, so you have now the oral and visual alert. So that's why you can hear the traffic plus the visual warnings. And if there is no changes in the path, the tendency of collision within 20 to 45 seconds. And the most potential threat among the 4 airspace is your resolution advisory. So meaning to say, it gives you now a resolution advisory to either go up or go down, just to evade a particular potential threat within different aircraft. And if you don't change any path, there is the most likely to penetrate that resolution advisory and create collision within 15 to or 20 to 40 seconds. In here, it's 15 to 35 seconds. All right. So these are your transceivers, your TCAS, I mean. All right. It's transceiver, TCAS transceiver has several limits that are set by the aircraft's wiring and computer's software program. So you have those advisory modes and limits. So it's you better rely on the computer because it's in its program. All right. So you have these components, gentlemen. So we have the TCAS transceiver, and you have a one-tap mounted directional antenna and bottom antenna. So you can find 2 antennas here, 1 top and 1 down. And of course, you have one transceiver. And you have also 1 control unit. All right, the TCAS control unit. And this control unit, gentlemen, is interfaced to your ATC control box also. Because just like we mentioned, this TCAS is the, what do you call this one? Rely dependently on your ATC. Without ATC, there will be no TCAS. All right. So, and of course, you have the 2 TCAS or the traffic advisory vertical speed indicator. So from your TCAS unit through your digital information sends a signal to your captain or FO, vertical speed indicator. That's why you have 2 captain and vertical speed indicator for monitoring. And of course, the system is also interfaced to your remote control audio units for the creation of maneuvers and warnings. All right. Yeah. Okay. So transmit and receive UHF signal for the detection of the intruders and manages all operation within interface. All right, so it computes the trajectory and provides signal to generate the appropriate intruder symbol in the BSI. All right, so this information issued from the transceiver is sent also to your FDAU for recording. All right, so these are mandatory parameters. That's why there is a signal goes to your FDAU for recording of data. And of course, since you have the loudspeaker that broadcasts the oral indication, it can also be recorded through your remote microphone. All right, both are used for transmitting and receiving your antenna. The text, the bearing of the intruder, which is the detection of volume of your TCAS number 2. And then, of course, interface to your ATC transponder. All right. So it depends on the selection whether 1 or 2 or one active at that time. So both transponder are linked to your TCAS transceiver and the active function, and they allow data to exchange between aircraft and TCAS equipped transponder. So the increase in surveillance. So the thing that it's integrated in your ATC transponder produces the identification and the altitude. All right, that's why you have interface also for your ADC. You have ADC1 and ADC2 for altitude reporting. You see this one, there is altitude reporting, which is produced from your ADC computer. It's not only the vertical speed, but also your altitude reporting system. All right, and of course, you have now the vertical speed indicators that gives you the visual information. So they provide information about the intruder's location, the trajectory, and of course, the system status message. Interface also to your RA. Specifically, RA number 1 only provides the radio altitude information directly to your TCAS. So you have a top or bottom. That's why you have the below 2 point. Actually, the RA is applicable only for 2,500 feet. So it uses that radio altitude information as a reference to determine the sensitivity levels. So that barometric altitude is still used to determine the relative altitude of the intruder. And you see this one, no RA information below 700 feet. Because of course, if the aircraft goes down, the tendency is there's a lot of aircraft on ground. And if you don't have that logic, it can give you a warning. Yeah? It can give you warning and identification that can mislead the interpretation of the pilot. So once the aircraft is going down, and at below 700 feet, there will be no RA now. All right. Okay, so yeah, we have the air data for your altitude reporting transponder. All right. And of course, it sends that one to our TCAS2 transceiver via the operating transponder. So it can be, you can choose either ATC1 or ATC2. All right, so yeah, over 2,500 feet TCAS uses the barometric altitude. So the operating air data computers also send the barometric vertical speed directly to your TARA BSI. So that's why you have the vertical speed directly coming from your ADC 1 to captain, ADC 2 to your FO. All right, and of course, you have your AHRU number 2 only sends the heading information in your TCAS. So heading So where does this aircraft comes from? You have the bearing and heading indications through your HRU and of course your FDAU to records the aircraft flight information. Okay, the system is also integrated to your GPWS. That's why in some instances, gentlemen, maybe you can no longer find GPWS. Maybe you can find enhanced ground proximity warning system, which is integrated also in the TCAS. All right. That's why in some instances, you can find in some aircraft T2CAS. So it means T2CAS, 2T. What is that 2T? The traffic and the terrain. That's why they are now integrated in one unit. All right. So in case of GPWS warning, the TCAS to oral warnings are inhibited. It means to say priority. Priority is given to our GPWS versus our TCAS 2 warnings. All right. Okay, so this is the system now. So we have different types of transponder that is being presented here. So we suppose that our own aircraft is flying at 10,000 feet and the intruder is equipped with mode A transponder. So what does it present? All right. So it will be received by the TCAS antenna and begins to interrogate the intruder within the detection limit. So the intruder now reaches the PA limit. The TCAS interrogates the transponder. All right. So communication now, communication between the two. So and the transponder responds in the mode A code. So it's just a identity without any information. At least you know that there is a potential threat within within 6 nautical miles. So during all subsequent interrogation, the TCAS to calculates the range between the bearing again and process the intruder's flight path called tracking. So this one now, these symbols now has to be tracked. All right, because of the transponder interrogation. And then as the aircraft within this within a particular limit now, getting nearer and nearer to your aircraft, it penetrates a another airspace called your traffic advisory. All right, TA. You have now the TA now. TA limit. So the TA limit now or the traffic advisory, if the aircraft penetrates that, it creates now a traffic oral alert and it changes to amber circle. All right. So and then the intruder does not transmit any altitude data because you don't know because that is only mode A. So therefore it is considered as being at the same altitude. So with that aircraft equipped with mode A only, TCAS does not provide resolution advisory. So the intruder reaches the RA limit. So that's the thing now. You have no resolution advisory. That's the problem for what do you call this one? Mode C only. But example for mode C or mode S, so the tendency it's much better because it gives you something like more precise indication. So not only to give you the identity, but also the altitude of the intruder. All right. And of course, it since it is mode C or mode S, so it changes in shape as it gets nearer to the aircraft and it can produce the oral warning traffic or descent. It depends on the altitude of the aircraft. All right, this one is mode S now, same. The only difference is the display and the oral alerts. All right. Same. So that's our system, gentlemen. So yeah, we have antenna. One top, one bottom. All right. So these are the locations of your TCAS antenna. All right. So your TCAS transceivers is most likely supplied coming from your DC bus number 2 and standby bus. All right, so see this one, you have the DC bus and your emergency bus. Yeah, it's emergency bus. The other one, your TCAS transmitter is bus number 2 and standby bus. All right, in the face of your TCAS transponder, yeah, TCAS, there is something like a byte test. So all you have to do is open the panel and press the test and wait for seconds, something like that. At the end of the test, the pass light illuminates and the TCAS test OK message is transmitted to audio alarm system. That's why something like you can see this one, illumination of LED lights to indicate if the test is pass or fail or there are faulty on the transponder upper lower antenna radio altitude heading RA or TA. Right. So in case of malfunction of one or more red lights on the front face of the TCAS transmitter, yeah, the receiver illuminates. So it means to say it will illuminate and indicates the faulty conditions. So these are the indications. All right. So it can give you pass or fail or something like red lights illuminating to those components interface of your TCAS system. So your TCAS transmitter, guys, is located on 80 VU. All right. So your TCAS control unit is powered by bus number 2. All right, so in your TCAS control unit, you have the standby. If it is placed to standby, TCAS is electrically but not operating. Normally, it is placed to auto, normal operating mode of TCAS. But you have also an option to place it to TA only. So only traffic advisory is operative. The radio altitude is not available. And of course, you have also the TCAS test post bottom, which is located also in the front face of the control unit for diagnostic. All right, this is how it looks like, which is located in the center pedestal. All right, and of course, you have 2 indications. You have your captain and FO vertical speed indicator, and the dial is, of course, from 0 to 6 plus minus 6,000. All right, and yeah. So the captain BSI is supplied by AC standby bus, and your FO TCAS BSI is 115 AC bus number 2. All right, so these are the features of your system indications, which can be found in your vertical speed indicator. All right, how about this one? So your TCAS, Right, once it is tested, then when depressed, the indicator will display test pattern. All right, 2 Honeywell vertical speed indicator. Okay, so the indications, gentlemen. So what does it mean? So we know that the symbols now, other traffic proximate, traffic advisory, and resolution advisory. But in some instances, you can see arrow up, arrow down. What does it mean? So indicates traffic is climbing or descending in excess to 500 feet per minute. But you have also plus, minus, and the number. So altitude difference in hundred of feet of the traffic above or below on aircraft. So if negative, meaning below, but plus means above of your aircraft. All right. So these are just the what we can see in the display units. If it penetrates within traffic advisory, then traffic sounds plus the symbols. All right, but you see this one, there is also another thing, gentlemen. Monitor vertical accompanies with the full range of preventive resolution advisories. So it is presented in a solid square. All right. And the most critical among the traffic resolution is the resolution advisories. All right, you need to, of course, once it is penetrated, the oral climb, 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 you can hear it, and the vertical speed shows you to fly to VS. All right, so most likely 1,500 feet to 2,500 feet per minute. All right, so these are just example. No need to discuss this one. All right. So there's a lot of things. So anyway, this one is for the pilot. These are just conditions how the TICAS system works. All right. How about failures? All right. So you have the traffic display. Flag appears in case of loss of valid intruders data. So we have the TD for traffic display failure. We have also TICAS fail. So internal failures, external failures, or even the transponder failures, or both VSI fails. You have the TICAS failure. You have also TICAS off. Once you place the selector switch to standby or off position. How about this one? RA, or resolution advisory. A flag appears with the following conditions. The vertical speed indicator is not valid, and the VS flag is when the VS flag is displayed. So you have the VS also. Vertical speed information invalid if you lost the ADC. air data computer is lost. How about blank? If you see blank, yeah, instrument failure. Fortunately, there is another vertical speed indicator, so it's a redundancy of the system. All right. So this is something like a simulation, gentlemen. No need to discuss this one. All right, so for test, if you press the test, what happened? So test can only be performed on ground. So aircraft configuration, you need to energize the aircraft, and then the ATC control unit to alt, and TCAS control unit select to auto. So auto and this one alt, and press the test post button. So check that the TCAS relevant symbol is displayed. So all the display information about the TCAS in the vertical speed indication, and then after few seconds, then you can hear now the TCAS system test okay sound. If the test is successful, and of course the software of your TCAS computer. And you can see also testing, so you can see TCAS, transponder, antenna, altitude, attitude, heading, RA display, and the TA display in okay, if they are good. If something like unsuccessful, then TCAS system test fail. All right, okay. So TCAS normal operation. ATC control box must be positioned to, it can be on or alt. All right, if on, it can be powered, that is the normal operation, but in alt, it can give you the altitude. All right, so see this one now, the flight envelope in which climb resolution advisory can be achieved without stick pusher or stick shaker activation, because there is a tendency, gentlemen, that during the maneuvering, it can cause the, what do you call this one? Too much steep, and it can cause the AOA to give you the stick shaker or stick pusher for correction of your something like stall configuration. All right, so that is your TCAS. Okay, I think ano pa? Ang haba ng ano, ang haba ng navigation. Malawak yung saklaw niya. So I think we can have one last topic, gentlemen, or pagod na kayo? Ano sa tingin nyo? Kaya pa or pagod na? Anyway, time is 9:14. Maybe isa pa. Last one, gentlemen, may mga ilang page na lang to. So, weather radar. All right. Oops. Oops, what happened? Stop. Okay, one last topic, gentlemen, before we call it a day. So next topic is your weather radar. So weather radar, gentlemen, is located in the forward bulkhead, and it is being covered by the radome. So that weather radar is a Primus 660 weather radar system, a lightweight X-band digital radar that is designed for weather detection and ground mapping. So the purpose of the system is to detect the storm along the flight path and give the pilots visual color indications and rainfall intensity. So after proper evaluation, the pilot can chart a course to avoid the storm areas. All right. That is the purpose of our radar system. It sends a pulses of signal, and then it what do you call this one? Bounce back as a form of echo principle. So you see, we have now the weather radar. Of course, it has a transceiver and receiver with the weather radar controller. So we have the weather radar controller. So, and of course, we have the EPIS control panel interface for ground mapping. And we have also the interface of your AHRU #1 for antenna stabilization. And of course, to generate and create the symbols to be presented in your EHSI, we have your symbol generator. All right. So your weather system detects the rainfall levels up to 300 nautical miles of 60 degrees sector on each side. Weather radar information is displayed on the EHSI. All right. In partial, compass arc, or in map mode. So this weather radar can also be used for ground mapping mode to display the ground obstacle. So warning the system performs function, weather radar detection or ground mapping should not be used nor relied upon the proximity warning or anti-collision protection. Don't use the weather radar. The weather radar is just for weather, all right, and ground mapping. It's not reliable for proximity warning. The proximity warning, you have a separate components there. You have the GPWS, or the enhanced ground proximity warning system. All right, so yeah, we have the rainfall intensity from level 0 to #4. So if black, so not detectable clouds, but if there is something like level 1, it increased the level of precipitation, it becomes green, it becomes yellow, it becomes red, or even intense. All right. All right, that is the weather mode, but for the ground mapping mode is most likely the same. So if there is no return, it's black. And then at least a reflective returns, cyan, yellow, and magenta for mapping. All right, so the weather radar is controlled from the weather radar controller. All right. allows the selection of modes, range, and antenna tilt. So you can control it by rotating the knobs to energize your weather radar. So selections are sent now to the weather radar transmitter antenna. And what happened is it generates an X-band radio frequency for the purpose of weather detection and ground mapping, and send 9345 plus minus 25 megahertz signal transmitted to the antenna. And as soon as it's detected level of precipitation, it will be returned back. Echo. Signal received by the antenna are received by the receiver, which process the signal. All right, and send them to your symbol generator that creates the symbols to be presented in your EHSI. All right, so the display unit, it can be full or arc. So all you have to do is to press the full arc in the EPIS control panel. All right, for your antenna stabilization, you have your AHRU number 1. It's only interface to your number 1. So example, if during flight and the AHRU number 1 fails, so it means to say there will be no antenna stabilizations now. All right, then in the selector, you have different selector switches and select for a given application. So you have the standby position. Standby position, keep the radar in a ready state while taxiing and loading. In the standby, antenna does not scan. And standby can be selected anytime if it is desired to keep power on the system without transmitting. So that is the standby. Now, there is this what you call the logic again for the fail-safe operation of your weather radar. If the aircraft is on ground, what happened? You have a signal coming from your weight on wheels, and the radar will put to a force standby. All right, for standby. Although maybe the selector is set to on, but since it is on ground, what happened? It goes to force standby. So, but you see, in order to override the force standby, you press the stub. Right? There is a push button switch also in the weather radar controller stub. And if you press that 1, 1, 2, 3, something like that, 4 times, it's not 3, it's 4 times. 4 times within 3 seconds. 3 seconds, then it goes to stop. All right, overriding your force standby. That is very dangerous. Why there is this weight on wheels logic? Because the aircraft is too lowered, and the tendency is if there is an operation of the weather radar, it can directly affect a person in front of the aircraft. All right, so this is your weather radar. All right, the weather radar is stabilized through your AHRU number 1. All right, so this is how it looks like. Gentlemen, you have your receiver transmitter antenna. All right, and which is integrated to an 18-inch flat flat plate radiator is fitted. All right, this is how it looks like if you open the radome. All right, warning, gentlemen, heating and radiation effect on the weather radar can be hazardous to life. Persons should remain at a safe distance from radiating antenna in order to be outside of the envelope in which radiation exposure level is equal or exceeds the limit recommended by FAA. That's why there is a fail-safe effect on the system. If the aircraft is on ground, it can cause the radiation to force standby. All right. Okay, so yeah, that is your transceiver antenna. So anything received, it will be processed and sent into your symbol generator for, of course, showing you the graphical representation of the weather in your EHSI. All right, our transceiver is powered by 28 DC and standby bus. So in normal configuration, it is powered by the normal bus, but in case of emergency, it will be powered by your standby bus. All right, so this is your control. Yeah, you have, this is the stub. So it can inhibit the weight on wheels. If you press 4 times in 3 seconds. All right, so you have the controls. So you have the mode selector. So you can see off, you can see standby, but you can see weather. So this position, select the weather detection mode. And then we have also the GMAP. All right. Okay, so these are the level of precipitation. So black, so the rainfall rate is 0.04 or inch per hour or millimeter, less than 1 millimeter per hour. Pero kapag medyo pabigat ng pabigat, so it can goes up to 1 to 4, 4 to 12, 12 to 50 or greater than 50. So para na siyang pag ganyan para na siyang undoy, di ba? Mataas na yung level of precipitation. All right, so you have also the GMAP, that is your ground mapping. All right, so maybe the color is the same, but the interpretation may not be the same as weather. All right, we have also the PF or the flight plan position. Puts the radar system in flight plan mode. That clears the screen of data. So you have the flight plan mode. And of course, you have also the test position, TST. So if you press that, if you select that one, so you can see test and you can see the test pattern in your EHSI. All right, how about the gain? Normally, you have maximum gain, minimum, and max. But in some other instances, much better if you don't turn this one, because as you rotate from minimum to maximum, the tendency of the colors, gentlemen, is it can increase. Example, for black before, it becomes green, and those green becomes amber, and those amber becomes red. That can cause the misinterpretation of the reflected signal coming from the weather radar. So better place it to at least not to the max. Then you have also your tilt selection now. So rotary control snap is used to adjust the antenna pitch from 15 to plus 15 in relation to the horizon. So this function enables the pilot to minimize ground clutter when viewing the weather targets. All right, and we have now the range also. So you have now the range arrow up increasing or arrow down decreasing. We have the RCT activates or deactivates the react mode, which compensate for attenuation of your radar signal as it is passes through rainfall. So RCT is a submode of weather radar mode, and select RCT force the system to preset gain. And then we have the stub. So stub pause button turns the pitch and roll stability on and off. When select off, the amber off legend illuminates above the pause button, but that is stub also. It's not only to give you this function, but if the aircraft or the weather radar is placed to force standby, just the note says you can press 1, 2, 3, 4 in 3 seconds to activate your weather radar. And you have also the SEC. Select either normal 12 loops or nautical miles. 120 is scanned for faster. Update 24 loops over not 60-degree sector is scanned. So is scanning. Right, that is scanning. All right, so you have you can see a lot of annunciators that can be present during the operations of your weather radar. So these are the indications. All right. So I think this is it, gentlemen. So at least for tomorrow, we still have tomorrow, and we still have how many topics to discuss. We have still the RA, the GPWS, ILS, and your marker. Most likely 4 topics. And then after the navigation tomorrow, maybe during the first hour of our discussion, after that, we can still continue on your structures. We still have 1 topic tomorrow regarding the structures. Anyway, structures is just something like a small topic. All right. Okay, guys, any questions regarding the topic as discussed in your navigation system? Maybe something like this are theoretical in nature, gentlemen, because of we are talking about principle of operations. So maybe if you are ANP, you are getting hard time in something like understanding the topic. But if you are B2, most likely you can understand this one. All right. So is there anything, gentlemen, before we end our day for today? All right.
Negative, sir.
Okay. So if none, then I think we need to rest now for this time, and see you again tomorrow. All right. Bye-bye.
Sir. Thank you.
Thank you, sir.
Thank you, sir.
Bye-bye,
Good night,
sir.
sir. Thank
Good
you.
night.
Sir, thank you, sir.
Thank
Thank you, sir.
Thank you. Thank you.
Thank you, sir Roy. Good night, sir.
Thank
Yes,
you,
sir.
Sir Roy.
Good night po. Thank you po.
Thank you, sir.
Thank you, sir.
Thank you, Sir Troy.
Thank you, sir.